So obviously attaching a stone to some kind of a branch and then using that as a means to accomplish the breaking of the coconut or whatever. But you can see the idea, knives and saws, things that were used then to accomplish an end. But what we need to think about right now, you guys, of course, as we said, now humans become an extension of machines. And the machine can't really function efficiently without the human. So it's kind of a reversal in a sense. And of course, just an incredible variety of applications of technology to create new tools and concepts to facilitate these ideas. One of the things we have to be thinking about, you saw it yesterday on the slide with the guy at the glass factory. So he's probably got, I don't know, would you estimate that weighs 5 pounds or maybe 10 pounds, 12 pounds, kind of like being pregnant for being, but it's hanging, on one side, and so you're going to have so it's just another ergonomic consideration with regard to the bulk and the space and the weight and whatever. Yeah, the potential irritation, chafing, whatever. So.
You said that, I was reminded my niece's husband is a police officer in Chattanooga. He was asking me about he's like, can you tell me if I need a chiropractor? Obviously he's never been one. So as I'm working with him and on him, he's telling me about how heavy his pistol is. I said, can you wear a vest? Because interestingly, the town believes that they've been informed that the police officer with a vest looks too scary because they look like they're in military mode, despite the fact that it's so ergonomically better for the officer. They said it's just too intimidating. I thought, wow, that's sad.
It's fascinating. This portrays again the interrelationship of this whole science. I mean, there is a societal, element. Talking a little bit about that. One of our friends, a Canadian chiropractor, developed a new pack for postmen, or people that come around home to home to home, and they have the strap, and of course they've got their big pouch and whatever. And he created a completely different, where it was both shoulders and far more user-friendly. It made it through about 7 layers of the process of final approval, and finally it got dumped because again they had some kind of an exclusive contract with so it's interesting, but it was by far superior design, but it's tough to break through in a lot of these things, so no terrible surprise. So looking at this, for example, you guys, on the left, we see an action or an activity, but we have a variety of factors to think about, right? So obviously you've got a cutting tool, that's first and foremost, potential for harm in that regard. There's noise, there's vibration, there's repetition, right? You got, even though it seems like a simple task, you have to think in terms of that. And it's not like what we do on our Saturday afternoon in our own lives, right? We do hobby activities. That's different than doing this for 40 or 50 hours a week, and then doing it for years on end. And of course, the potential stress. And this is pointing out again the mechanical effects. Say we looked at the idea of constant gripping, but then also the vibration, and so additional considerations. So it's really all about design again. Design and use of hand tools, therefore, primary importance in the application of ergonomics. Fortunately, many hand tools are not designed for safe and efficient use by humans, especially for repetitious activity and application. And here's a cardinal rule. Again, as we said, these time-honored concepts and precepts that guide the design, or let's say the whole science of ergonomics, is really like this is one that you really have to be sensitive to. To minimize stress, fatigue, and predisposition to repetitive microtrauma disorders, it's important to design tools to allow the worker to maintain a neutral risk. Maintaining the wrist in neutral posture provides the greatest strength of the forearm, musculature for gripping, and dexterity. Have you guys done that little experiment where you're, go ahead and do this for a moment. You guys take your left hand. If you're right-handed, this would be, if you're left-handed, do it in reverse. But let's say you're gripping now, if we're a hammer handle. Okay, keep your wrist neutral and squeeze as hard as you can. Now put your wrist into maximum, shall we say, and then grip. Do you notice a difference? Do it in any of those modes, right? So the neutral wrist is stronger and obviously, again, far less compressive to the carpal tunnel and the related soft tissues and so on. So just to maximize, what nature gave you is of obviously a logic, mechanical engineering, advantage, so to speak. And this again shows these green zones and amber and red, and so just a visual to help you to get an idea where we should keep and be observant for where the wrist is in space. So obviously it's also a means by which you can help people understand that using these little demonstrations can be really useful. Before I forget, right now I'll show you something that we teach in this class. Is not designed as a therapeutic intervention, shall we say, encounter, but I would tell you that in terms of, see, humans are hunter-gatherers, therefore our flexor muscles are far greater developed than our extensor muscles, right? So most of our activities in the workplace engage our flexor muscles, so they're chronically shortened, right? So here's a simple thing that you can, from the computer operator, the typing all day long, to people who are using hand tools. And again, you can do this. I find it a little bit more effective when you're standing, but I think you can do it where you are now. Just sitting, observe this maneuver, and then this is the most simple, easy, way in which you can really stretch those flexor muscles. You'll feel it pretty good, I guess, in the bellies, right? And of course, you can get people to try to get into the habit of doing that, and maybe 2 or 3 times a day. As we said, idea of stretching and stretching programs, just figure out which muscles are chronically shortened or contracted, and then these are the ones that need to be stretched. You can do generic stretching, but it may not still address, what you're really trying to accomplish. So just an easy way to think about that. On your left, you'll observe a drilling procedure, although it may be that this tool is another function. But what I would point out to you is that this tool is, if the image were larger, you'd see that it's suspended from a line above on a spring apparatus. And in fact, it allows the worker, as you can see, to retain essentially a neutral wrist. And it looks like there's some exertion going on here too, but one thing, obviously the weight of the tool usually is like you have to exert a counter force to hold it in space. In these instances, the weight of the tool may be actually an advantage because it's spring suspended. And so if it were a heavier tool, it would drive, more efficiently into whatever procedure you're doing. So you want to think in terms of that. These are pretty standard now at workbenches where hand tools are used. It's common that they be, if it's like an assembly operation where it's a repeated activity, obviously, though, it often is really limited to that function. You may not be able to use it in a horizontal mode or, having the dexterity of movement. But of course, it is designed to accomplish that end. In a repetitive task, it might be the most appropriate design and application. For all of these, though, as you can see, the notion is the design of the tool is what allows, maintaining the wrist in that neutral posture. So,
there's some kind of torsion absorption.
pardon me?
There was kind of a brace on the arm. Is that a torsion absorption?
Backing up, which one? On this guy?
That apparatus going over his, by his elbow, the forearm?
Oh, I see. I think that's a stabilizing mechanism, yeah. It helps him to maintain that position. And again, there may be a counterforce involved with it as well. I don't think it actually is involved with the function of the tool in terms of like activating it, you know, like instead of, so I'm curious about it myself now that you bring it to my attention. I hadn't noticed it before.
There's a occupational therapist in our area that patented something like that. I was wondering if that might be his, but for tools that have like drill snaps
Yeah,
that start and stop that have torsion,
yes.
it was to absorb the torsion, to disperse the forces of the torsion.
That may exactly. That's one issue, you guys. The ratchet type tools that have, like if you noticed, like if you've been at the tire place where they've, you know, done the tire maintenance and they switch them from one. So they use those ratchet tools to zip, and that's that real sharp, but there's an immediate abrupt stop. And that can be really a difficult thing to deal with. And so you're saying your friend patented advice that helped reduce that. That's kind of cool. I wasn't aware of that. So exactly, that's innovation to facilitate. Obviously, it's a very efficient tool. Zip, you know, like you got, instead of doing it all by hand, that's a very repetitive task, right? You could do that, but if you use that automated tool, that's kind of cool to realize that there may be a solution to that, because it's been a problem, and it's good that the group is reminded of that. So obviously the thickness, shape, length of the tool for each individual worker, again, to try to tailor it, and that's not easy, particularly again when you deal with, you know, the 6'4", 280-pounder to the, you know, very small, perhaps female worker. Using the same hand tool obviously may produce a whole different set of stress factors. So, and here's an item that all of us have to think about, right? The engineers, you know, who design these things may never have, you know, the opportunity to use them or the obligation to use them to realize, you know, what they should be thinking about. So obviously we would say collectively, whatever anthropometric data is available for a certain work group, people who are, you know, in the ordering department of a, you know, company that might have 600 or 800 workers, they might have somebody that continuously deals with ordering supplies and materials and all those things. And rather than thinking generically, they ought to be thinking in terms, well, we've got 1/3 of our workers who are female. We've got, you know, another 1/3 that are whatever, with that consciousness in mind, and then giving people opportunities to see if there may be appropriate fits, I think just makes pretty good sense. And of course, vibration, again, we bring this out because it is such a significant and potentially ubiquitous phenomena for certain occupations where, you know, it's literally inescapable, and it's every single day. Hand tools that are notorious for the production of undesirable levels of vibration. Sustained vibration, as we mentioned, is a vasoconstrictor. That's a physiological or pathophysiological mechanism. Results then in a variety of consequences, primarily circulation. And so obviously, as we said, tobacco is a contributor to that as well. And then the other one being cold. So here's a concept of some abatement, right, for reducing the amount of vibration that might be involved with hand tool design. Probably the worst culprit among all of these is the jackhammer, but keep this in mind, you guys, it really does go back to the frequency, the hertz frequency. The jackhammer, that's a, you know, it's a pretty significant, if you think of a waveform, you think of, you know, like the sine wave goes above and below, right? And then if you think of the harsher currents, like a tens unit has a square wave, and that's intentional so that it triggers a different neural pathway. So this is the idea of the jackhammer, even though it's a very heavy tool, and but it's got a coarse waveform, right? Compared to a tool that might have a very, very fine, you know, think of a dental tool in contrast, right? But you know, dentists and dental hygienists, they're vulnerable. They're extraordinarily vulnerable. So just kind of think about it in that light as well. It's not just the heavy physical forces. It can be these micro-vibratory phenomena. And like in vehicle operators, it used to be, as we said, it used to be considered that it was strictly the vertical, the bouncing, the 55, when the speed limit was 50, they used to have a kind of I guess one would say a slang term for that. Bottom line to it, though, then they came to the realization that it's more than the vertical compressive force, it's also rotary, and it also is horizontal, the drivetrain and all of the other considerations are included in that. And of course, they're not compatible with the usual, as we know, the harmonics of the body. It's an electrical waveform as well, right? So if it happens to be synchronous with that, it's not going to harm. But if it's like dissonant rather than resonant, well, then we run into problems, and then it contributes to this vasoconstrictive effect. And as we said yesterday, the disc, it does have blood supply, but only through the vertebral bodies. The bone, has blood supply, but then of course it's the end plate that provides the nourishment to the disc. And if that's constricted, well, then of course the disc doesn't get a healing nourishment. So, Chad.
Yeah, Joe, I just wanted to something popped into my head as you're describing what's going on with vibration here. I'll just share my experience. When I first started going out and doing ergonomic work, and I considered vibration as a culprit for potential injury, it was easy to see the guy running the jackhammer and understand that vibration was probably not very conducive for good health over a long period of time. But actually what statistics and what research tells us is that although jackhammering does bring large vibration forces and certainly can cause injury, a much more common injuries take place from the vibration that we don't always see. And one of the biggest culprits is the vibration from the machines that the employees work around, because it's continuous and long duration. Individuals can only jackhammer physically for so long, and then they need to allow their body time to rest and recover before they can continue. But somebody standing next to a machine that's vibrating for their entire 8 or 10 hour shift sustains that vibration, and that micro trauma over time will cause more trouble than even this. So just when you're out there and you're looking at vibration, don't always, it's easy to get focused on the guy who's physically running it. But certainly take a look at the equipment in the area and understand that if they're on concrete without anti-vibration mats or without rubber-soled shoes or all of these other factors, vibration can be a very dangerous thing in those settings too.
Thanks, Chad. And as you observed yesterday, we talked about some of the consequences of neglecting this. So chainsaws, jackhammers, drills, grinders, sanders, deburring equipment, nail guns, all kinds of, as well as the machines themselves, large machines that do a variety of tasks, have especially motorized equipment. So certainly relevant considerations that Chad brings out and we talked about before as well. So the variety of syndromes, all of you probably have encountered some or most of these in your practice. Carpal tunnel, trigger finger, also known as stenosing tenosynovitis. Ganglion cyst, Dupuytren's contracture, Dequar veins, lateral epicondylitis, tennis elbow, pronator teres syndrome would be examples of it. There are others, but those are the ones that are probably most common, and also there's fairly good clinical information that's related to them and intervention strategies. This again, the reminder of the importance of our attention to soft tissue things for chiros that are kind of like so rather rigidly focused on the adjustment, being capable of doing, wonderful things. It's also, again, a component of the total application of the interventions. We have to realize, of course, that there can be local microtrauma far distant from and separate from the vertebral column, although it can have, as we know, a reflex relationship up and down the cord and whatever as well. But just for all of us to realize the critical nature of paying close attention to the soft tissue destruction that can take place at a local level. And then just this point on carpal tunnel, for example, on average 25 lost workdays for every victim of carpal tunnel. The concept of surgical intervention, the release of the transverse ligament, is always controversial because in many cases, while it does dramatically relieve symptoms, it often still sends the worker back to their same job. And that brought on this syndrome in the first place. And so that's another thing we have to be really attentive to. Certainly the surgery can be life-changing. People can finally sleep. They haven't slept for 3 months, and so on. The suffering that's associated with that, and a lot of them, of course, if caught early, we can do wonderful things for. But without question, there is time when, obviously the humane thing to do is allow that to be done. But of course, that's only half the picture, because if a person doesn't do something to intervene upon why they developed the problem in the first place. So employers frequently would assume that, well, send them for surgery, then we'll be done with it attitude, right? And of course we know that that's short-sighted. Always consider the idea of the proactive position. This is another consideration. To avoid overuse syndromes of the hand, wrist, and forearm, it's best to distribute the force required to activate the device over multiple fingers, choosing hand tools that provide this option. And then that's one issue. And then the circumference of the tool, especially for the smaller hand, or let's say the tools that are designed for men. So in this case, obviously these handles are fairly slim. And again, for some men, that would be too narrow, right? That's the other point. But what you observe that makes this unique is here you can probably use 2 or possibly even 3 fingers to activate it rather than a single finger, which would then cause trigger finger, right? That syndrome where it's an overuse disorder. There's a number of conditions similar. One is called gamekeeper's thumb, trigger finger. Again, that's in that family of tenosynovitis or stenosing, tenosynovitis. This is another example. In this case, you can probably activate it with your entire, finger application, again, preventing that concept. So, in cutting tools, the biggest challenge we have, of course, is keeping them sharp. And maintenance, therefore, is a significant issue for any of these. Obviously, it's going to create the need for a greater amount of force. Over time, of course, that's going to lend significant challenge. Here we have the consideration, of course, of ergonomic design, along with the notion of making sure that they're kept sharp. So yesterday we talked a little bit about jigs and fixtures, and we showed you an example of a fixture that kind of, even though the intent was good, the end objective, didn't meet the standard. So a jig, though, let's define that. That's the opposite in the sense, instead of stabilizing the part, it's intended, let's say, picture in your mind, maybe going to Milwaukee, Briggs & Stratton, and where they manufacture these little gasoline motors for lawnmowers and all kinds of applications. So if it's coming down the assembly line, a jig is designed so that now it can be flipped to its side, then it can slip this way, and then it can be... So it's kind of like on a ball-bearing apparatus, so that the worker can maintain their posture, raise lower, and of course then having that capacity for maintaining, it permits the object that's being worked on to tilt or twist, rotate, bend, or invert, give the worker easier access to optimize their posture, not of their total body posture, but the posture of their wrist, for example, posture of their elbow. Remember the load moment concept, right? So we want to kind of be thinking of that. And then notice this. It says jigs are usually constructed in-house by the firm's engineers to suit the given need. Why? Because again, it's a unique application. There's probably no use for it in the general public. So it's not found in hardware stores. So they have to engineer it to deal with the specific task that they're challenged with. And this gives me an opportunity to mention this term, you guys. A lot of times the building engineer is the guy who ends up doing these kinds of things. But curiously enough, it's kind of like, janitors now have a new title, right? the point is that they're not graduate engineers. Think about that, right? They're not truly what you would consider a mechanical engineer with a degree and having, all of that knowledge base. And so put that in perspective. They often are there, and their title is engineer, but you got to realize you may need to coach them, is what I'm saying. And again, the other opportunity to touch on for a moment, and Chad, I think you'll really relate with this, is that individual is key in many, many instances. And by the way, you really need to nurture relationships with those people. Anybody in middle management, keep in mind, as we said, there's layers. There's upper management, then there's middle management, and then there's the regular workers, right? Do you think that all three need to be on board? Big time. Any one of those three not on board, what happens to your program? So if you come on as being the world expert, right, the hot dog, and you're pushing, the people, what's the likelihood of success, folks? So this is an example. You may say, well, this guy isn't an engineer. They call him an engineer, but he's really a dummkopf. If that's your attitude, keep in mind, many of those people probably grew up on a farm, right? And they knew how to do stuff because they just had to, do it for practical reasons. And many of them extraordinarily practical people. They find inexpensive ways, and they use the roughest, coarsest approach, and they get the job done. Except that, of course, they have very limited understanding of, ergonomics, if you will, or how the body operates and this interface between. So this is where you guys can work as a team, but make sure that you respect their skills and also their position. Because anything that threatens their position, you got to realize you need them. You need them rather desperately. So just kind of keep these subtle little ideas in mind. It's really an important consideration. And then yesterday we observed, as we said, the fixture, on the other hand, is a rigid, non-mobile device used to stabilize the part or component, usually so that it frees up both of the worker's hands, right? So that, and as we said, a typical bench vise would be an example, which is, of course, commercially available, but the device you saw yesterday is also an example of a fixture. Similarly, and again coincidentally, just as we saw yesterday, fixtures are also commonly designed or retrofitted in-house to accommodate the specific need. And of course, they tried the cheaper approach. I mean, had they had the awareness, they probably could have built, that mechanism, still use the foundation, whatever. They could have modified it in such a way that it would have allowed the worker to, have it user-friendly, so to speak. But in that case, obviously, they didn't have that consciousness, so to speak. This is an ongoing controversy and discourse in terms of many corporate managers in the past insisted on their workers using one or more of the various types of externally applied support braces while performing lifting and manual material handling tasks, such as this one. I think this is probably the one that became extraordinarily popular at Home Depot. I think many of you, just as you, do you see them anymore at Home Depot? They're not, in use anymore, but for maybe, 5 years? And so things like this tend to go in waves, in a sense. They kind of become a fad, and then, of course, they watch their data, and they look at return on investment and say, well, because they were provided by the company. There is data, there are data, if you will, that are supportive in some measure. The science literature shows that such back bracing have shown have not shown consistently positive outcomes. However, such devices may have some value if workers are properly trained in their use. And part of this, controversy suggests that constant use would result in atrophy of, say, the abdominals or the spinal muscles, and that has been shown not to be true. But if that's the case, then of course we know that they're not doing very much. If they really did hold you from, these excessive motions and stresses, well then in fact in theory, there should be atrophy, right? Well, that's never been shown to be. I attended a conference in Vermont a bunch of years ago where some of you may have heard of Alf Nachemson and Gunnar Anderson. They're probably some of the most world-acclaimed low back specialists in the medical world and occupational medicine. And it was kind of an anecdote shared by, these guys are both from Göteborg, University of Göteborg in Sweden. And so they asked Dr. Nachemson whether or not he thought back bracing was a good idea. And after quite a bit of dialogue, pro and con among the audience as well as the presenters, he said, well, I think then they might have fewer mosquito bites. That was his kind of, a little bit tad of sarcasm there. Bottom line, though, what we really want to stress is that fit is an issue, especially for female workers. Obviously, the trunk, right? there's not like a female rendering and or a male, style, because obviously the shape is uniquely different. And so men usually their trunk is more vertical, and therefore they fit better for most men. Okay, that's one issue. The other thing, though, is they're often hot. They engender, especially working in hot environments, they can be irritating, and of course perspiration and so on. Those are issues surrounding compliance, right? So of course, if the workers enjoy using them, that's another thing, because what we want to stress about that, we'll back up for a moment, this last bullet, negative outcomes were observed if workers were forced to use them. Okay, then what do? You have this issue again of morale problems, right? So workers can be encouraged to use them, and those, usually who find them to be helpful, frequently, of course, they will have some ongoing low-grade symptoms, and it may relieve some of those symptoms, and those people might prefer to have the use of the device. Most of these are designed to be worn outside of the body, and many of them in the early days, they would say, well, only snug them up when you're going to be doing, heavy manual labor. So you might go portions of your day when you're not lifting, then they were supposed to leave them loose when you're going to be lifting. But if you're working in a warehouse and you're lifting constantly, well, that's another issue. So these remain somewhat controversial, folks, and this is why it's intriguing, Don. Dr. Brown brought to our awareness yesterday a new device that I personally, admire. I think it's uniquely designed and may well have some value. I've experimented with it somewhat, and at my age I have some disc issues, which most of you will probably have, partly occupationally induced, because as you know, the ergonomics of being a chiropractor is not without its consequence, right? Because we have a very physical lifestyle. If we're a typical chiropractor doing manual type of care, for long hours for years on end. So to that end, I personally have found this particular device quite helpful at like 8 hours of working on landscape activities, for example. So I'm personally open about the potential that they can have merit. And I think many of you use these devices in your clinical practices, especially during the acute recovery phase of acute low back disorders. So I would say remain open-minded about them. And then I think largely it's like a lot of therapeutic interventions. It's all about patient selection, right? It's kind of like if you're a good candidate for it and there is a good acceptance of it on the part of the patient and good compliance, then of course I think it can be very therapeutic. Plus it may have a placebo effect, right? Anything wrong with that? Not in my mind, right? It's okay with me. Go ahead.
We talked about the Hawthorne effects a bit.
Yeah.
Is there a
Sure.
technical word for like the legal CYA type thing?
Oh, in terms of...
I'm thinking in an industry where if there's a lot of potential for lawsuits and that, attorneys or whatever might say, well, if you don't at least offer some option or some solution, then you're negligent and
familiar with the Hawthorne effect, but
Right.
I didn't know what it was called.
Yeah, I'm not certain. I know, again, the broad umbrella, with regard to governmental regulation is that the employer can be held liable if they knowingly place workers in harm's way. Now, does that mean necessarily that they have to offer like an intervention, a preventive, like it's across the board, everyone who's going to be using this? It's kind of like, I don't think so. And when they try to do that, there's going to be pushback and resistance and morale issues. This is why we really stress this idea. In your role, you can be the intermediary, right? You can kind of help them to understand. If you try to force these things onto people, there may well be a boomerang effect. There may be benefits to some, and that's where you, with your clinical knowledge, and again, selection, right? Proper selection might be a really useful tool. Go ahead, Chad.
This brings up a good point, and in the third session of this series, we're going to talk about some medical legal, so we'll leave the longer discussion for that point. But I can tell you that there's more litigation in reference to companies mandating employees to do things than there is for companies who don't provide the opportunity for it. So in a situation like this, and I don't know that low-back-ups are particular to this, but I do know in general, companies will invest a lot more in their legal counsel for things that they're going to mandate employees do, as opposed to providing them as an option. So just understand that too. When your recommendation to a company is to mandate all employees do something, you might have one or two people amongst that group that are contraindicated for their own personal health reasons, and if you put them in a situation, then the company becomes legally liable. So it gets back to Joe's comment about it being a selective process. I would highly recommend that you strongly consider anytime you're going to mandate everybody do something. There's some liability in that. We'll cover that in the third session too.
Yeah, again, the idea of engaging the worker, right? I mean, they're going to be the participant in the process, and if they don't have a voice in the matter, then the likelihood is, human nature will prevail, right? And as Mark Twain said, there's a lot of human nature in people. And yes, there are, workers who just look for opportunities to, go to their lawyer. And so that's another issue. Not everyone who is working in a work environment has the family attitude that we're all in this thing together and let's work together toward a harmonic, outcome, because they're definitely, keep this in mind when we talk about, for example, drug testing, alcohol screening. Gosh, right now on the tip of my tongue, maybe some of you who have been in that training would remember what % of addicted individuals. I mean, 1 out of 7 Americans is addicted to either drugs or alcohol. Just realize that, 15% of the population. And the great majority of them are working. I think it's 78% are working. Okay, they're working right next to the people who are sober. And what does that put everybody into a whole different kind of mindset? A lot of them become, that develops psychosocial, a lot of them become paranoid. They have all kinds of sickness-related expression in their lives. And so just kind of realize that, unless you take serious means, and of course more and more employers now are doing, drug and alcohol screening, but then you have those circumstances where, hey, the workforce is already dwindling. We talked about that a little bit in rural communities. It used to be where, there used to be small farms. People would have a beautiful lifestyle. They'd run 120 acres, and it was kind of like a hobby farm, and they would have a full-time job during the day. And they were, people with high integrity, and they were hard workers, and they, it was kind of like a balancing perspective. But today, there are 2,000, 4,000, 10,000, 20,000 acre farms, right? And so you don't have that anymore. And therefore, this population of available workers, and especially like for seasonal work. So this has changed again. It's a cultural change that all of us have to put in perspective. And so in your role of working with employers, it's what we have to confront. The next question comes with gloves then, and obviously, in many instances, they may be required on various work activities. Examples are when exposed to temperature extremes, cutting activities and for sanitary reasons. Example, surgeons, meat cutters, food handlers, whatever, they are obligated, for microbial reasons, to have to wear gloves. And of course, with that, though, comes decreased grip strength, increased forces required, reduced dexterity, tactile sensitivity may be a trade-offs in the use of gloves. So I think all of you would easily recognize that as to there's pros and cons to the use of gloves. Here would be the example again of mandatory use of gloves, but as we said, it's a slippery environment and it's a cold environment, and so you've got a variety of struggle factors that would be related. Huge selection and varieties of types of gloves. Here you can see where the fingers are open to allow dexterity, and yet you have at the gripping point where you're doing most of your gripping, and you've got this pebble, kind of a corrugated material that allows a firmer grip. So there's the uniqueness of that style of glove. And then this is kind of intriguing as well, because shock absorption for vibrating hand tools and whatever, there's quite a few of these styles currently available. And I would just go to your search engine, just click in those terms, and you will find just a vast array of companies and manufacturers and styles. And then one thing that I like to recommend, though, and have people be aware of, one of my friends is Dr. Tom Jetzer, is a medical doctor who is specialized in occupational medicine and ergonomics. And interestingly, about 10 or 12 years ago, he patented a unique approach to shock absorbing gloves, vibration abatement gloves. And actually it's like you literally inflate it, and it's got a bladder, and it literally has been shown to be dramatically effective in reducing the effects of vibration. It's just that layer of air. Now, there's a very, very fine line between too much and not enough, and so that's part of it. But I know he was excitedly telling a group of us at a conference we were presenting at an event at I think it was a group of engineers, where we were providing concepts in terms of ergonomic design and whatever. And he had just that week signed a contract with Ford Motor Company when they were still building Ford trucks here in St. Paul. That was one of his first major commercial contracts for the sale of his patented design. Then, though, a little tongue-in-cheek, he said he also got some kind of a trophy award from a little company in Milwaukee that some of you might relate to as part of your hobby. Right, motorcycle. So Harley Davidson honored him at their annual convention, because again, motorcycle, obviously is a lot of vibration, and if you're on that bike for hours, so apparently it was useful for that application as well. So anyway, that's called Ergo Air, and you can go on the web and you can learn more about it, but that's the trade name of that particular product. Let's take a break now, you guys, and when we come back, we'll get into a topic area that you would need to have at least some conversational awareness of, although it's not quite as dramatic in terms of the neuromusculoskeletal. It more has to do with safety issues. It has to do more with preventing human error, so to speak. So anyway, take 10, and we'll come back and continue our discourse. Testing, back on track. I don't know about you guys, but one of my pet peeves has always been signage on highways. I just think that highway engineers sometimes must have some kind of an interesting death wish in terms of they, I think, don't realize that when a person is confused while driving 70 miles an hour and not sure about exits and all of these interesting things, that you know, you often have to make a decision within, you know, milliseconds, and if the signage is inadequate or inappropriately positioned, that would be an example of what we're talking about, folks. It's all about the idea of reducing human error. It's so coincidental. Yesterday we talked just slightly about the ergonomics of designing an aircraft cockpit. And so coincidental, some of you know that I do a commute every day from Owatonna. I've been doing that for 27 years. And so I've taken up audiobooks the last 20 years. So it's been a wonderful way in which, you know, to pass the time, as well as it's educational, entertaining, and all of those things. So I've had my second or third liberal education during all of these opportunities, reading from anywhere from 50 to 100 new books a year on every imaginable topic. And of curiosity, just this morning, the novel that I'm reading currently is it's called Unbroken, and it's the story of World War II. And here's the intriguing thing that was announced in the story. This is a nonfiction novel about a certain airman, and it was stated that 1 out of 6 of the airmen that died in World War II died in combat. 6 out of 7 died in accidents involving human error, involving mechanical design, involving all of these things where aircraft were crashing into each other. They did a lot of night flying, for example. 70% of the fatalities were non-combat. It's kind of mind-boggling, because it really, that's why this is so important, you guys. And in the environmental, you know, the environment of the workplace, usually we don't have those kinds of, you know, fatal kinds of consequences sometimes, though. But this is why we want to put due emphasis on, so the human workplace interface system may be defined as a combination of one or more human beings, one or more physical components interacting, bring about given inputs and predictable desirable outcomes. So implicit in this definition, the existence of some communication lines or links between the human operation and the physical components. So controls and displays then provide such links. A control is a device that transmits information from a human to a machine. Picture the steering wheel of a car or a tractor or a forklift, or the brake pedal, right? Those are means by which you can control your vehicle, your accelerator, and, you know, so the brakes and the steering wheel, those would be example of what we call a control. A display, on the other hand, is a part of the work environment, usually a device that provides the operator with information relevant to the task at hand from the machine. So consider the pressure gauge on a steam boiler, or simply as your speedometer on your car. That's a display, right? It helps you to know the operation, and you can make adjustments based on, you know, what you learn from that. And of course, on the surface, that would look pretty simple, but clearly you can realize it's not quite as simple as it seems. The proper design of display and control devices is essential for the safe and efficient system performance. For this reason, the design of these devices has been a subject of exhaustive ergonomics research throughout the decades, and it's unsettled to this day. It really is. This research is ongoing. However, the following represent currently held beliefs regarding these study outcomes. So, as we reflected with you, these are sort of the time-honored concepts that if you follow these, you'll be in a position that there's a lot of agreement among these research people, right, where they obviously don't all agree with each other, but I think you can feel a certain level of safety, and these are concepts. These basically, again, are from government websites. I mean, this information is certainly available to you, and you can expand on it. I'm kind of summarizing it for you here. But of course, again, it's a subspecialty within the world of engineering and occupational health. So sometimes a choice has to be made to determine which human sensory modality will be used to receive certain information. Obviously, the most common are what you can see and what you can hear, right? So visual and auditory. When appropriate design, the tactile sense as a means of conveying necessary information too. Remember yesterday I talked about the shape of the control of the flap or the, you know, the landing gear of the aircraft. The tactile sense can be really relevant in some instances as well, especially in, say, the dark, right? What if you're in a dark environment? You can't see, right? And of course that lever can't talk to you. I mean, obviously the auditory mechanism. A lot of variables to think about. The seemingly simple decision is in reality quite complex. When considering the visual presentation of information, the designers may need to examine the host of human and environmental variables. Among them are the following: whether to use scotopic, which means black on white, or white on black, or color to convey the information most appropriately. We gave as an example that exit sign. And again, as we said, is it doing what would be optimal? Question becomes varying capabilities related to relative or absolute visual discrimination. And of course, the idea of color blindness is another factor, not common, obviously, among the general work population, but it's still real. What do we have to think about? Well, obviously, glare. Are people actually able to see it as well as they should? Contrast ratio between the object of interest and its background. Changes in light intensity during the day. Of course, sometimes the sun, will. So you'll have a variance in the amount of light available. And then how capable are and how quickly can people adapt to light and dark environments is all part of what has to be considered. Distance is an issue, how close for optimal viewing. And obviously that would determine the size of it, also the visual angle, if it's directly in front of the person, or if it's off to the side or at a diagonal. And the time available to view the object of interest, angular view, object movement, and possible visual distractions. And almost never will be an environment where there aren't distractions, right? So you can anticipate that, it's all about just how many and how significant the distraction might be. The auditory, similarly, if one is considering presenting an auditory stimulus to the worker, another list of variables has to be taken into consideration. Obviously, the sound intensity, the sound pressure level is measured in decibels, and then the sound frequency. Talked about that a little bit, the hertz, and again, compatibility with our hearing mechanism. Human reactions to sound, the sensation of hearing, is a complex function of both intensity and frequency. Masking one sound in the environment reduces the sensitivity of the ears to another sound. So one can drown out the sound or the signal, and therefore, of course, there's an infinite range of variables of sounds in a work environment, as we touched on the idea of pounding and grinding and sawing and stomping and human chatter and all kinds of, variables. And so these are what we call competing sounds, right? Anything that then a message that may be consequential in terms of a human danger has to find its way through all of that, right? It's kind of like through a maze to finally get the attention of the people that have to get that information. So general principles when deciding which would be the best, most effective, either a display of the visual or auditory. Visual presentations, if there is relative or quantitative values, usually again illustrated by numbers, numerical values, percentages, or information such as that. Usually you would do that in a visual format. Part of it because you can go back to it. I mean, if it's auditory, it's just once. It's kind of like when you're, you leave a phone number with someone, you get a phone call and then you call them back, but they're not there. Well, do you do it? Do you always do two? I mean, I really encourage you folks to leave your phone number twice. And again, usually it's best to shorten that message, because obviously if they, so often, they'll speak so rapidly and they hang up, boom. And if you miss one numeral, it's kind of like a computer. Your brain is a computer, right? If you miss one, you click on the wrong button, garbage in. So what I'm suggesting again, in terms of conveying communication optimally, I just encourage that, and this is what visual permits you to do. That's why, the phone that has the caller ID, it's really cool because the phone number is there. So while you're jabbering, and they haven't even given you their phone number, you can make a note of that, right? Because again, it's like communication is the key to most human challenges, right? Usually it's shall we say, it's the cause of most problems, and it's also the solution of most problems. Inadequate communication is a serious human dilemma in our culture. In domestic situations, literally think about that, right, in terms of human interaction, communication skills. I think is not taught adequately in our society, not appreciated for what value it has. And of course, as we stated, it also becomes then the solution for many of the things that are important in conducting a society appropriately and peacefully, if you will, in harmony. So communication, it can't be emphasized enough. And so, and again, visually, if it's a complex message or the message happens to be required to be longer than just a few words spoken. Now, visual is preferred also if the message must be referred to again at a later time or in addition to the initial stimulus. There's a number of displays, in other words, where you've got to look at like 4 or 5 all sequentially. If you have that in writing or in a printed mode, it would be preferable to an auditory. Or if the auditory system of the worker is already overburdened, it's a noisy environment or they've got other things that their focus of attention is what they're listening to, then you better give them a visual stimulus. If noise limits the use of an auditory stimulus. And then also keep in mind that if the worker happens to be in one position or not, if the worker is moving around, well, obviously then they can't see what you're trying to display to them. So it's optimal if they're situated or in a work environment where they're in one position where they can refer to that information. Now, the auditory is preferred if the information is simple and the message is short. A message will be not needed to be referred to later, and the visual system of the worker is not already overburdened. Pardon me, let's reverse that. See, it's just the reverse of what we just said. In these cases, again, they're concentrating and their attention is on all of the visual stimuli, let's say the computer screen. Well, then it may be desirable to give them an auditory signal instead of. So just think about that. One or the other may be overburdened, and then choose the opposite. And then sometimes both, particularly in emergency situations. When immediate action is required as in response to a warning signal, both senses should be used whenever possible, with the hope that 2 is, in that case, better than 1, that the 1 is likely to get through for some people, and the other one may be getting through for the other. However, when this is impossible, the auditory pathway is the best choice. And again, you can usually, like a written sign, or even a signal on your computer, unless it's accompanied, there's a written printed word on a computer screen is one thing, but unless you've got your sound, see, that word can't speak to you, but a signal, like a siren, can increase in decibels, and it'll get your attention, right, if it's a true emergency situation, and you can see the common sense of that. In the majority of industrial work environments, about 80% of the useful information workers receive is visual. Okay, hence the following guidelines are used for visual displays. Highest priority visual requirements must determine the general layout of the workstation. So again, that depends on what we spoke of earlier, where the worker is situated and whatever. The operator should be positioned to face the primary visual field with no interference of the line of sight to primary visual displays. Again, common sense is the efficiency of communicating the information. The designer must take into consideration the available light, too bright or too dark, for optimal viewing and interpretation. Worker orientation in relation to the visual message must be considered. Simply, again, the ease of visual accessibility. And then the next question is the content and the size. In other words, determine, like say, as for emphasis, we say fine print is not practical. Some of you in the back, well, I could have made this smaller to emphasize the point, right? So putting that in perspective, you have to think in terms of how to best convey this information so that greatest accuracy in terms of the interpretation of the message. So obviously the visual acuity of the individual has to be taken into consideration. Color blindness may be another factor. And usually it's green and red, although there are people who do also have impediment in other light wave forms. So putting that in perspective is an issue. And as we said, the stereotypical understanding of red and green and the symbology of that, but if you're colorblind, well then of course you may not recognize the semaphore. And I suppose if you are conditioned to that as you learn to drive, well, then you adapt, of course. But in an emergency situation, as we said, when stress takes over, well, then this could be another issue. And user friendliness. Visual displays should be grouped according to function. When displays of the circular scale type are grouped for viewing, inspection, or monitoring tasks, the null, or the what would be called the neutral, normal position, should be arranged systematically for ease of visual scanning, such as the 9 o'clock or the 12 o'clock positions, things that we are already conditioned to think in terms of, that we can relate to, and so that it makes it more user-friendly. And as we said, the expected in mind. In other words, what the person would usually anticipate the message to convey. For dial-type designs, information expressed should be minimized, providing only that which is necessary, and gradation is simple, kept simple. And again, the example of that is like, again, on your dashboard, right? In the old days, every vehicle, every car had an oil pressure gauge, right? And that was cool, as long as you had if you were a motor guy, right? Then of course you understood what it conveyed. But what percent of the American drivers now would be able to interpret so it's really only an issue when, let's say there's a problem, now an idiot light comes on, and now you know that you have to take some action. Usually on modern automobiles now, so much of this has become very sophisticated, and of course we're all benefited by that. I think, for example, fatalities on the highways have dramatically decreased since the 50s, when it was probably at the highest point in time. Something like, we were at one point something like, thinking in terms of nationwide, I'm pretty sure we're almost down by a third of what it used to be. Highway fatalities, and of course, single greatest contribution to that was freeways, where vehicles were all going in the same direction rather than meeting head on. The second thing, of course, is seat belts became a huge difference. Of course, now airbags is another huge issue. What single factor, though, was one of the most dramatic and probably least anticipated, again, coincidentally, was established by an organization called MAD. Some of you can relate to that. And that was a women's organization called Mothers Against Drunk Driving. That saved 5,000 lives a year from the very first year that they started to send their message. And of course, that resulted in the dram law. You guys know dram law, where bars were no longer permitted to serve alcohol, and they became legally liable if they served alcohol. See what I'm saying? All of those things came about as a result of cultural change, which has now resulted in almost, not half, but about a third less fatalities on highways. A combination of these varying, intervention strategies that have been helpful. So thankfully, again, our automobiles are much safer, they're built better, they cost a lot more, of course, but they last longer, far more trouble-free, and of course, far less stalled vehicles, which again is always a hazard on a highway, right? I mean, now if I commute, if I see a stalled vehicle once every 2-3 weeks, I mean, that's about all. And of course, in the winter, it's different because, of course, of spin-outs. But put that all into the equation, so to speak, in terms of, the design and the engineering and the thought that went into that, in terms of much of it, again, had to do with ergonomics, right? Had to do with creating user-friendliness of a machine and its controls and its displays, right, and its application in our daily lives. And so this concept, again, population stereotype should not be violated. So in other words, if you're dealing with a circular scale, you'd expect that the needle should go clockwise, right? I mean, that's what we would anticipate it to be. And if it doesn't do that, well, then it's going to be confusing. So have to, vertical scale should go from bottom to top. Again, if you think of something expanding in, however, the velocity or the flow of something, usually then if it's in a gauge, it should show it from bottom to top. Horizontal scale should go from left to right, and just because that's what our subconscious is already conditioned to be responsive to, so to speak. And then style and size of the display. Obviously, the fixed scale moving pointer designs are generally preferable to the moving scale fixed pointer. I think you have to think about that for a moment, but it's common sense. Capital letters and numerals in visual displays are read most accurately when the ratio of stroke within the height is about 1:6, or 1:8 for black on white, and somewhat higher for white on black. Again, how the brain perceives things. So just again, the basic rules. Then moving into control devices, as we mentioned, this is the second communication link, how you convey information to the machine. Again, that closed loop concept. Based on the force requirements, two distinct categories of controls can be identified. And then, as you can imagine, controls that require little manual force, such as push buttons, toggle switches, small hand levers, and rotation knobs and dials, all of which can be easily manipulated with a worker's fingers, right? So that's one category. And then controls that would require more muscular effort, hand wheels, cranks, heavy levers, and pedals, all of which involve major muscle groups of the body to operate efficiently and correctly, especially the arms and the legs. So again, you can pretty much anticipate that. Now with power steering, of course, that's reduced the stress of the, the control of the vehicle from the use of the steering wheel, and of course power brakes in terms of that, far fewer clutches, right? So, it's reducing the requirement of thought process involved with controlling the vehicle. Most of them now are automatic shift and whatever. So these are all subtle things that we've kind of taken for granted, and now they're commonplace and they're part of our daily lives. But of course, they all had an original design concept. Somebody gave serious thought to improving the potential for it to be more efficiently operated and more safely operated and so on. Correct choice and arrangement of controls is essential if machines and equipment are to operate efficiently and correctly. Following guidelines will help ensure relatively trouble-free control interface between humans and machines. All controls should be located within the maximum reach limits of the worker, preferably within 75% of the maximum reach when he or she is in the normal operating position. Yesterday, you remember the young lady that was in that fixture mechanism and how far she had to reach for those little red control devices on the side would be an example. That was well beyond that point. Most frequently used controls should be located at the most convenient place, near the hand or foot normally used to operate the particular control in question. Control choices should take into account the anatomy and functions of the limbs. Fingers and hands should be used for quick, precise movements and actions, while arms and feet for operations requiring force or heavy physical exertion. That may include endurance. If you think in terms of holding your foot on the accelerator, if you had to hold your thumb, for example, on the accelerator to keep the car going at the appropriate speed for hours on end, well, you can imagine the fatigue factor, right? So obviously the foot accelerator is a better choice. So in simple relative terms that you can relate to. If correct sequence of operation is important, controls should be placed left to right. If not, they may be grouped according to function. Again, the stereotypical anticipated use of whatever the machine's goal is or function, you want to be respectful of that. Hand-operated controls should generally be placed between waist and shoulder height, pretty much, again, that power zone that we spoke of. If fast reaction time is required, controls should be located directly in front of the operator rather than to the side. And then sufficient spacing should be provided between controls to preclude inadvertent or non-intentional operation. When space is limited, either separation guard should be provided or dual mode, both hands safety design should be used to prevent accidental activation. If you can relate to this idea, guys, like, you can see the logic of separating a control so that you don't, think of those cockpit pilots again, where those controls are placed right next to each other. Had they been separated, that might have been one intervention. And of course, the idea of a lot of these devices now have an infrared beam that will not permit you to activate a device until you have both Hands have to be, it's a means by which it simply will not activate until you have, that's what's being described here. It's a safety measure that you can't activate it with one finger or one hand. You have to have both involved. So these are interesting strategic devices. I'm sure, Chad, you've encountered a number of these where, particularly where people have lost digits or lost a hand, where now they're using an infrared. It's very much like the security lights that are engaged in buildings where they're preventing robberies and so on. It's a similar kind of technology. You can see on a machine how this could be very useful. Comment, Chad?
Yeah, I'll just add a comment in here, Joe. They're really out in the field. You'll see two different things. You'll see the beam, and when it's interrupted, it disables the machine, and or the two-handed activation thing. One of the things that you should do as you're observing or communicating with employees when you're out doing some ergonomic work, employees find ways to disable these safety measures because they're a hassle sometimes, or they've been working on this saw for the last 20 years, and some hot shot came through and put this device on there and they don't like it, so they just a point of emphasis to make sure that the safety measures haven't been disabled by the employees. It's something to consider as well.
Part of that human nature thing again, Chad, right? Because of course they know best. Make on switches difficult to activate by accident, and then make off switches easy to locate and operate. Push buttons, toggle switches, rotating knobs suitable for operations requiring little movement or muscular effort, small travel distance, high precision, and for either continuous or stepped operations. It's valuable to have this concept of click stop so that it's incremental, click, 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 so you know that you're gaining or you haven't activated it until you've heard 3 clicks, and that's equivalent to a certain velocity or whatever else your desired output is. Cranks, hand wheels, long-armed levers, and pedals are suitable for operations requiring greater muscular effort over long travel, comparatively little precision. Of course, the subtlety now of operating a lot of these things. If you think of, I always think of a ship captain and this big wheel that they used to operate in the old days of the. In terms of that, the subtlety of even a quarter of an inch of movement, can have a profound impact. So even though it looks like one would say that would be little precision required, there would be exceptions. To aid in the control identification, as we said, the tactile sense should be made use of by coding controls by shape, size, and surface texture. And again, to be reminded of what we spoke of earlier. But of course, this is just one example. There may be other environments where this could be really sensitive and critical as well. Where power-assisted controls are required, artificial resistance cues should be provided so the operator has the ability to sense the action taking place. I don't know if you are aware of this, folks. For a while, they were designing keyboards where you simply touched it. There was no downward compressive force involved. You just touched it. Like a touch screen, that's fine, but unless you had feedback that you actually had done that action and it was thrown away, obviously, they no longer continue that, you need this feedback information that you actually activated what you intended to do, and the keyboard is a good example of that. Really not necessary that simply touching it could activate it, but it didn't find acceptability in the workplace. This is a required phenomenon for it to operate efficiently. Control should be provided in a positive indication of activation so that malfunction can be immediately identified. So, the awareness that it actually has taken place. As with visual displays, population stereotypes should be incorporated in control display, and control function relationships, such as turning a knob clockwise, should result in a similar movement on a display needle, or a toggle switch up for on and down for off. All of those simple considerations obviously have to be a component of the design. Any discussion of the capabilities and limitations of humans in the performance of physical tasks And control choices would have to include at least the major following factors: strength, endurance, fatigue, range of motion, speed, and accuracy, and combinations, right? So keep in mind there are people who would be amputees, and you have to put them into the situation as well. You have to design for the worst case scenario and anticipate that it would not have to be used commonly. So we went through that rather quickly, you guys. As we said, it doesn't directly have to do so much with day-by-day neuromusculoskeletal intervention or prevention. But as you can see, your role would be broader than simply the biomechanical aspects. And we touched on that yesterday when we said there may be chemical hazards or other environmental factors that you may be the only trained health-related clinician type. Obviously, those individuals who are working in such environments also had this idea of a fatigue factor. You all know about olfactory fatigue we touched on. Well, the idea, if there is a hazardous chemical, you probably know, for example, that natural gas has an odor. See, it's normally odorless, right? But for safety reasons, they've added a chemical. It smells like rotten eggs, right? So it's a sulfur-related product added to natural gas so that people are warned. But if it's subtle and very, 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 very gradual, then they may be conditioned to it and not realize it, and of course not, therefore, take action that might prevent hazardous situations. So, go ahead, Ross.
Visual, you didn't mention patterns, but I wonder if in the industry, as you said before about fatigue of hearing or smell or whatever, but for me it was always a sensitivity of if a pattern was either very small or dots. I mean, a long time ago had migraines, and that was always a scotopic sensitivity.
Yeah.
And I wonder, in the industry, did that get identified that there are some patterns that are either too busy or actually create motion if a visual sensitivity is
yeah, with certain people, I think you know that certain seizure disorders, similarly, people that struggle with motion sickness is another category. So again, in those instances, it's somewhat reliant upon the employee bringing their, quotes, handicaps, made that aware to the employer, and then as we touched on yesterday, there is then the need for the employer to react to that. In other words, to make reasonable accommodation. And again, usually that can be done, but sometimes it's very, there's very little that they can do for that, and it may, in fact, ultimately, if it's serious enough, like recurrent migraine can be really, really disabling, right? And therefore, it may preclude that person, having that particular work environment. But you're right. I mean, there is more subtlety here. Our purpose is more general right now, and then, though, to help you to know that there's a lot of effort and energy that's gone into this. As we said, it looks kind of simple on the surface, but as we say, again, I still encounter, highways where the signage is really, really pretty poor, even after all of the science effort to, make it as really visually or any other signal that is designed to communicate to you. Obviously, it's a huge component of the ergonomics, if you will. But you're right. There's going to be exceptions to the rule, and I don't think it's likely that they're ever going to solve all of it, because it's the human uniqueness of every individual. So it's a good thing to bring out, though, the fact that employers have to be sensitive to this. And as again, during down economic times, that's when workers are reluctant to bring out any indication that they've got any kind of handicap or physical challenge or some other issue, because again, they're very conscious of the potential of losing their job, and never a casual kind of thing. Let's continue with the consideration of looking at this science, huge, and its implication, right, in the last 20 years particularly. It's really become a tremendous shall we say, advantage in terms of the potential for preventing, human suffering. It really is pretty remarkable to consider what the potential of robotics are for the future. And you can well imagine immediately if you can reduce, the amount of physical challenge that humans are having to struggle with, and can be reduced to a simple computer program, right? Design some software that can do things that would have required incredible amount of human exposure. So to that end then, though, there are certain advantages, one to the other. So let's review them and give you some sense for how it should be addressed. So the design on the part of managers and designers regarding the use of robots instead of humans can be somewhat complex, especially when considering the cost-benefit ratio and return on investment. I would highlight and underline that concept, folks. It's the single most important deciding element. Probably it will remain so for a long time. I think though, that the entire world of electronics is just like every other thing, is that initially their cost is profoundly higher than what it might be 5 years from now or 10 years from now. Just think of a simple laptop when it used to be. And you could easily spend, and now you still can, I know with high-end, I suppose Apple, you can still spend a couple $1,000s on a laptop, but my goodness, you can get one, for $300-400, right, nowadays. So a lot of this technology is drastically coming down. Partly it's because they can then become mass-produced, right? So many of these robots, again, are designed to do a very specific task. So if an industry, let's say, take any industry, they may have a very unique challenge of a work process that has to be addressed. And therefore, the robot designers have to be really focused on that challenge. And it's not, like we say again, where one size fits all, or you can go to the robot store and take it off the shelf, right? So in that instance, those often have to be tailored to the unique challenge and therefore very expensive. So this issue, cost-benefit ratio, return on investment, is often the deciding element rather than whether or not it's going to be a valuable tool. That's understood. The question is, at what point is it going to pay for itself, right? That's a reality that we always have to be thinking about. So looking at this now, humans are generally better in their abilities to sense changes related to visual, auditory, tactile, olfactory, and taste stimuli. Not many robots can do that, right? You can't taste, smell, hear, whatever. Again, their software may at some point, right? They theorize that robots may well be able to do a variety of sensory capabilities that they currently are not doing, but certainly they're on the drawing boards, and they're going to be in our existence, certainly your lifetime, maybe not mine, but it's very likely that a lot of these considerations will be the capability of robots in the future. Robots obviously can't make sudden changes in their operation based on new data. Humans can react, and based on new data, you will respond to anything that would be a threat or a need to make a decision to make a change. Well, a robot is going to just keep chugging along. It'll keep doing it until something were to stop it from doing that. So humans can store and recall general principles and rules regarding decision making. I guess you can say they can reason, right? Humans can reason. They can adapt to procedures to meet varying situations. Again, their ability to change based on new data, and then put contingency plans into effect when there is obviously an observed reason to make a change. Well, then humans can do that quite efficiently, and more efficiently, obviously, than the computers. Humans can perform varied physical tasks at random, apply new methods. Again, random is not a feature of the software. It's programmed to do very explicit things with very, predictable behavior, if you will. Applying new methods to create new solutions, the ability to think through and make those decisions, develop priorities. Again, all of this you can readily understand where the human would have an advantage. And in fact, sometimes the absolute critical need for the human to not replace a computer, because the job process requires a lot of this contingency plan, so to speak, changes of desired outcomes. Now, let's look at robots and how they may be advantageous. They're generally better in their abilities to sense low-level stimuli or small changes in certain stimuli within the work environment. So subtle, in fact, that the human would be delayed in that response. What would be a simple example in our daily experience? How about the thermostat? See, the temperature in this room is very, very constant, right? But for many and most of us, it would probably have to change 3 to 5 degrees before we started to feel either a chill or it's too warm, right? Whereas, Honeywell figured it out a long time ago, even before the popular use of traditional computers, or, if you will, but the idea of a servo mechanism, right? It's a feedback loop, but it's extraordinarily sensitive to very small or low-level stimuli. Handles standard situations without error, because human error, as we said, is one of the conditions of the human experience. We become distracted. Robots, they're not bothered by that nice-looking member of the opposite gender or whatever, right? Our distraction potential is very real in the workplace. Store and retrieve information quickly and accurately. And of course, I might say, would you probably add the word abundantly nowadays? I mean, it's mind-boggling to think of your little handheld device. It used to, require a room half this size to. My brother Harry, who is essentially the benefactor of what we refer to as the Swery Center, started his career in the computer world back in the 1950s, and his training actually was involved with the military. And so in the gradual evolvement of his understanding of this contribution to society was very much at the basement level, so to speak, and it was literally working around hard drive systems that literally took up the space of this room, which now we can, carry in our lapel pocket, so to speak. Mind-boggling. And of course, that's, going on now 60 years, so we have to think about it in that light too. Huge, huge. And you wonder what 10 years is going to bring, right? Put it in that light in your experience, right? It's going to be continuing probably to become even more with far greater capability. So I would say I would add probably the word abundantly. Accurately, quickly, and abundantly. Certainly all that is the capability of robots. Yeah.
I did hear about this warehouse where everything was, the forklifts, everything was robotic. Actually, they didn't even have any lights on. They just punched in what they wanted and
Fascinating.
no human whatsoever, and doing for a big warehouse.
It's kind of like your lawnmowers, right? You can program, or your vacuum cleaner now. You can. So yeah, it's fascinating. But save that energy. You don't need light if it's going to follow the exact same path all the time. But it's pretty remarkable when you think of the human creative process that's involved with all this stuff, you guys. It's quite miraculous, really. I'm in awe of it, honestly. At my age group, I'm certainly in awe compared to what we grew up with as kids. And of course, many of you in the younger, generations perhaps take this more for granted, but I'm still in that childlike awe of how far it's come in my lifetime. It's just mind-boggling. Robots, again, can process large quantities of data. That's that abundant element. Make repetitive calculations both rapidly and accurately. Perform multiple functions simultaneously. One thing about the human brain, you guys can only focus at one thing at one time. You probably remember the concept of present time consciousness and how critical that is in terms of our life experience. and focused attention. I think it was Thomas Edison, or maybe Einstein. I think it was Einstein said that the difference between mediocrity and genius is one's ability to focus your attention. And of course, computers do that with extraordinary efficiency, right? So in the sense of like, well, that's genius, but as we pointed out, humans are prone to distraction and loss of focus, of attention, and for a lot of reasons. Sometimes, of course, see, a computer wouldn't be able to save its life or run out of a burning building, right? It would just keep chugging along. Get the idea? I mean, so, there are trade-offs in all of this. As much as there is to admire and be in awe of, there's also these other components, trade-offs. Robots can exert large physical forces for long or short periods with no decrease in efficiency. They never get tired, so to speak. Withstand many stresses without decrement in service. Operate continuously without fatigue, essentially 24/7, 365. Obviously, however, with careful human monitoring, right? Because, of course, it's a machine and it's got a shelf life, right? It can break down, and of course, it can have faulty software, and it can self-destruct, and we know all of those already when we have computer, crashes, so to speak. So, putting that into perspective, though, most of the time, this is extraordinarily predictable, and it's a great advantage. Operate in a patterned manner, given known inputs, desired outputs. Even though robots are expensive to build and maintain, it's important to know that they put this in perspective, folks. They never go on strike. They never ask for a raise. And they don't go on vacation, take sick leave, or whine and complain. So what is that worth to the employer? Well, as we say, there's, they have to look at all of these factors. And, in terms of, instead of putting on a third shift, right, you just purchase some robots that can do the work of 10 or 20 people and do it all night long, and nobody has to think of shift work anymore. But of course, they still need some monitoring. So all of that, some people said, well, robots are going to be one of the greatest threats to human, let's say, employment, obviously job opportunities and so on. There was a time during which, however, they said that for every robot, it takes 6 engineers and, people to build them, design them, maintain them, and all this stuff. So it's different jobs. It isn't going to eliminate jobs. It's just that you're going to have to retrain to be able to be a designer, be a, operator, so on. So all of that fear has been, not well-founded in terms of robotic society actually creates jobs. And obviously, we've all witnessed, that in our time frame. So let's kind of summarize this issue with robots and when and how they are considered to be a cost-benefit ratio. And it's when, for example, in a hostile environment, okay, such as extremes of heat, cold, radiation, caustic, toxic, or noxious circumstances prevail. I think you all probably know that one of the innovations, although it's not new anymore, but Saturn. Remember when Saturn moved its plant out of Detroit and they went down south somewhere, down to one of the Carolinas, I believe, to build their factories. And they had a very unique sort of interest in ergonomics. For example, prior to that, GM happened to be the innovator where, in fact, to install like the undercarriage of a vehicle in the old days, the workers all had to literally be working overhead. They all had to be literally craning their neck hour after hour, installing, the muffler and the undercarriage, whatever. Well, in the Saturn plant, they sort of flipped it on its side, and now the workers could stand vertically and they could do all of this with much greater ease. And still, it's a very human endeavor, so to speak. You're not going to find robots that are going to install a muffler on a vehicle, right? Or for that matter, if you think of robots, threatening work environments. Can you picture robots handling? Although this is a stretch, some people are believing that it actually could take place. Like people in a nursing home that robotics are going to take over the demands of transfer of patients in a sick bed in a hospital or so on. So there's mechanical assist, so to speak, but can you picture robots installing a new toilet in your home, right? Or you know what I'm getting at? It's not likely to. There are many, many of these occupations where, in spite of our automation and incorporation of these high-tech kinds of devices, it's not likely that robots will come in and do most of the tasks, in fact, that we are familiar with that are such a significant ongoing issue with regard to neuromusculoskeletal disorders. Basic lifting tasks in many, many environments. It'll never be robotized, so to speak. However, you can well imagine hostile environments, extremes. To that end, also, I think Saturn, I think now it's across the board. I don't think any automobiles are painted by human beings anymore. Paints on vehicles have become, that's another major science, and of course there's a lot of chemistry involved, right? And again, it's pretty toxic, those fumes, all of the things relating to that. Robots do all automotive, at least in the American cars. I don't know if that's necessarily true in other countries, but I presume so. For this reason, right? That would be an example of activity that now has been completely automated. When excessive load demands or significant repetition of the exact same physical action is required, that's when robots obviously have great advantage. So resources before we close this hour. As we said, vast amount of available information regarding the science of ergonomics on the web, more than ever before. Highly regarded, government-sponsored, few common. What's unique about it, of course, is, as we say, it's common domain. It's readily available. It's state-of-the-art, although some of it, by the way, is aging, and quite frankly, more than I would have thought, is still was printed in the 90s, but it's core information, and it need not change, because it's like gravity. It's not likely to change a whole lot. Certain concepts that we try to share with you this weekend are going to hold as constants. That's a nice thing about it. It's kind of like being a chiropractor compared to, depending on pharmaceuticals, which change every 6 months, right? Human anatomy, human nervous system, is pretty consistent, even though we know it has become the victim of our environment. Sadly so. Our world is different than in the days of D.D. Palmer. Right? Remember when he talked about the 3 causes of illness? Well, and of course one of them was toxicity. But what he wasn't, kind of appreciating is what was going to happen in the next 100 years, wherein literally 100 million new chemicals have come into our environment in the last 100 years. And of course the unique thing about that is that, the one thing that was the unpredictable, it's often referred to as Pandora's box, literally. I mean, the fable of Pandora, releasing all the evils into the world. Of course, it was a woman. You can anticipate that, right? Most of history, right? History is his story. History. So to that end, though, what's interesting is that the combined effect. See, a chemical has a predictive, action. There's a chemical action or chemical reaction. But when you combine them, when you put 2 chemicals, you don't necessarily get, 2 added to 2 more. You don't get 4. You might get 5, or you might get an unpredictable number. You know about open valences, right? You get attractive bonding in chemistry. Pretty soon you have no predictability of what's going to be the outcome. And this is what we touched on yesterday when we said that most experts are saying now cancer, for example, is environmentally induced. So in healthcare, when you're dealing with, chemical, approaches to healthcare, well, obviously, just imagine how fortunate we are, you guys, and that we can deal with some pretty significant constants, right? Human anatomy, human physiology, all of those things that we once learn the core concepts of, we can depend on that to be, something that's very predictable. Of course, what we are countering, of course, often are these environmental insults that come from the food that we eat, the air that we breathe, the the 4 considerations of life on Earth for its survival, right? You guys remember that? Air, we need oxygen, we get that. But you know that the amount of oxygen in the air is dramatically different than it was when our parents were born, for example, again, when D.D. Palmer. So that would be the amount of sunshine, the second element necessary for life, right? We need sun, we need sunshine. And of course, you know, the amount of sun that's available to us anymore is drastically different because of what we've done to our atmosphere. And again, food, well, the source of food, of course, is the soil. What have we done to our soil? What has, you know, modern technology and agricultural techniques in terms of lacing that soil year after decade after almost a century, half a century already of, you know, changing that composition of the soil, again, for profit, right? Primarily profit. Did you know that the largest lobby in Washington is the food industry? Think about that for a moment. Think of MSG, right? Is in 5,000 foods. Recently I heard that MSG causes addiction to sweets. Put that in perspective, folks. Think of our obesity and our diabetes and all those things, right? As good a chiropractor as you are, folks. You get it? You get what I'm talking about? And this is what we're facing in terms of our culture. So air, you know, sunshine, the soil. What's the other one? There are 4 components, right? Water, right? Water, absolutely critical. So there's another one, though, that we take a little bit for granted. I think this morning a lot of us are a little bit victims of it. Sleep, rest. We need sleep, we need rest, right, for survival. You know, we can go a certain number of minutes without oxygen. So many days without food, so many days without water. We can live in a dark environment. I mean, you know, think of people that live in Antarctica, or, you know, in the Arctic Circle. But of course, over time, they still need vitamin D, right? And so, but the notion of sleep, again, has become another really serious issue in our culture because, again, especially in our young people, I think you know that it's becoming of epidemic proportion, how serious the lack of sleep in young people is, and of course for a lot of adults as well, mostly because we are overstimulated, and again, we're not, you know, have the fortitude to push the off button on the remote. I mean, obviously, again, there's so many temptations to watch that extra late night show or whatever it might be. And the average amount of sleep that people are receiving, of course, is contributing. Why are we talking about this? Because these seminars are driven with one focus, and that is wellness, right? So we have to broaden our perspective. We have to include on our menu, you know, in terms of our considerations, that it's a very broad perspective. And then for those of us who tend to be sentimentalists, I think there's another component of life and survival on the earth, and that, of course, is love. It's simply caring, starting, of course, between infant and mother, right? If that isn't there, what would happen? I mean, would we last 1 generation, 2 generations, right? You get where I'm going with this, you guys. Again, that's why we emphasize this idea of holism, right? The body, the mind, and the spirit are interrelated, and again, that's core chiropractic philosophy. And I think the public is getting hungry to hear this message because it's starting to really wake up to the realization that it's their responsibility, right? Part of the definition of holism, the patient assumes the primary responsibility for their own well-being. And that's part of our message in the workplace as well. When we were training the Minneapolis Postal Service, we would say to them, don't do this for Uncle Sam, do this for you so that when you retire you can still play with your grandkids. Why would you want to prevent spine injury? Well, do it for yourself, right? Don't do it for Uncle Sam or the Postal Service because they don't care. I mean, they won't care if you die tomorrow. I mean, you'll be replaced quite easily, right? So kind of put that onus into why workplace. In other words, you got to have buy-in, right? You have to get that understanding. Don't do this for your employer. Do it for yourself. Do it for your family. Do it because you care about yourself, which is, I think, a real key issue in terms of understanding health. I honestly believe, folks, there's a great deal of struggle, in terms of conflict. By that I mean guilt, fear, anxiety, resentment, anger, bitterness, all of those things. They're not part of the mainstream healthcare message. And again, somehow, I mean, when I talk about this with our students, they say, well, you know, I'm not a psychiatrist. I'm not going to talk about that with my patients. And I say, well, look, you don't have to be a psychiatrist to tell people that hatred and health are not compatible. And you have a responsibility to tell your patient that if you believe their health or their disease is related to the fact that they have an unresolved conflict, a hatred, a resentment, a bitterness, anger, all of those issues, I think, can you even imagine living with under those circumstances and thriving? Impossible. So yes, is that going to be part of our message to our, you know, workplace wellness talks? I think so, folks, and do it courageously. And believe me, you'll have more receptivity than you'd probably imagine. You know, the idea of political correctness and avoiding the idea of talking about spirit. Well, bottom line to it, you guys, is that it's an intangible force. I mean, you can say it's, you know, not scientific. However, I challenge you and ask you, for example, is grief real? That's pretty intangible, isn't it? How do you measure it? How much grief can you put in a test tube? How much anger can you put on a microscope slide and look at it through a lens? Put some kind of, you know, you got to measure it, you got to quantify it, you got to say that's science, right? But you see, we have to expand science to embrace these considerations of looking at the intangible factors in our human condition, if you will, which I believe many times is a core to, you know, the underlying issues of, first it starts as dis-ease with a hyphen, you all realize that. And of course that's where chiropractors usually have its best result, right? We realize that once that irreversible pathology, you know, that's too late in the game. So we have to remind people again that do this while you're still healthy. Do this while you're still relatively healthy, right? And in that regard, I think your message is going to be really, really well received, folks. And quite frankly, do you think you're going to get this message from, do you think the workers is going to get this message from the friendly physical therapist? I don't think so, folks. The friendly medical doctor, I mean, bottom line to it, they live in a different world, do they not? They have a whole different agenda insofar as their perception and their appreciation for, you know, the balanced perspective of healthy living. So I think you guys are treasured, you know, to be treasured in society. Again, unappreciated at this point, not fully valued, because again, you know, how do they know about us? How many television programs, right? How many, where the chiropractor becomes a local hero. I mean, it's like we're not at that point, but we have that potential. So it's a matter of, you know, polishing that gem, that remarkable thing that this gift that we have for humanity. That's kind of what I'd like to share with you guys. So anyway, as we said, these sources are readily available to you. For example, these are a couple that you can go to. Gosh, you know, maybe, Andrew, this is what we could have, you know, the CDC, because that's what NIOSH is, guys. It's regulated by the Centers for Disease Control. So maybe go to that website. You might go to that piece that I found previously, wasn't able to retrieve right now. But anyway, this is the accurate website. And OSHA, of course, has got huge amounts of information available. Literally, look at this, you guys, of notable importance. OSHA and NIOSH have published industry-specific ergonomic guidelines for a wide variety of specific occupations. So meatpacking, beverage distribution, foundries, nursing homes, shipyards, grocery stores, poultry processing, right? I mean, so we don't know what kind of opportunities are going to arise for you, right? But just realize that what we wanted to share during this weekend was generic in a sense. It's kind of like broad application for many of these things, but then there are these unique specified, you know, specially designed informational sources that you can access that I think will be very valuable to you. And then, as we mentioned, NIOSH has publications. See, these are printed formats. See, it's an ergonomic guideline for manual material handling, and it's the number This was published in 2007. That's fairly recent. Like I said, some of this stuff is getting kind of old. Selecting non-powered hand tools, a specific publication on that. Ergonomic programs, primary based and workplace evaluations of, here again is at MSDs, but it's their appreciation of what it's about. For construction workers, and remember what we said yesterday, that this is an extraordinarily high exposure work population in great need of our assistance. So NIOSH publications includes ergonomics for construction workers. Again, another website, so on. So, and then if you are a reader and enjoy that instead of television, this book is pretty remarkable, really. Kodak's Ergonomic Design for People at Work has really been one of the time-honored private publications, non-governmental, right? So that has its own unique twist. Observe, though, 681 pages, but beautifully illustrated, gives lots and lots of wonderful examples. So upstairs in my office, if ever you come by socially, I can show you my library. I mean, usually I'd have to bring it down on a big cart, and when we would have elective classes on occupational health, we'd stack up all these books, and I found that the students usually went to the bathroom instead, but nonetheless, that's why I didn't bring my library of occupationally related books. But in the practical world, it's mostly on the web. So again, that's why students just walk by it. They know that, and you guys know that as well. But just realize, of course, in my era, it was all in the printed format, and a lot of this still remains in that light. The Bureau of Labor Statistics will really provide you tremendous amounts of data regarding the who, the what, the when, the where, the how, and what occupations, what demographics. This is another really interesting site. Bureau of Labor Statistics is the website. So from the conclusions, you'll observe the science of ergonomics draws on information from many fields, attempts to unify this diverse body of knowledge, to optimize the interface between people and their work environment. And again, in essence, it's designing for human use, that whole idea of providing the most optimal environment between people and their workplace. While this underlying philosophy seems simple, application of basic engineering principles to the life sciences continues to represent a significant challenge to those concerned with occupational health and safety, hence the need for more research and more data that represents things that are relevant and practical. Now, even though we're saying thank you, and as if we were ending now, the next portion of our training for the rest of the day will deal with this other really demanding challenge, because of course currently 70% of all work done in America is done in what you guys are doing right now, in the seated posture. So we want to put some serious attention to that. So take a break now. We'll meet up again at 10:30 and we'll go back to work. Well, welcome back, you guys. As mentioned, this has become a remarkable challenge for the healthcare community, not only from the standpoint of the consequences that were once thought to be the greater concerns in terms of like visual and fatigue factors surrounding, operating a computer. But we've come to realize the consequences of prolonged sitting, and we'll be touching on that a little bit later, but the data on that is becoming quite alarming, and so we're grateful that you'll have an opportunity to take a look at this. And so the first consideration, you'll see the title again. You'll see the seated worker as opposed to the sedentary worker. And this is, again, that subtlety relating to political correctness. The connotation, right? The title of this presentation, therefore, we avoid the use of the word sedentary, because sedentary implies someone who is a couch potato, lazy, or perhaps not very productive at their job. So for the sake of harmony and, if you will, political correctness, keep this concern in mind as you mingle in the marketplace. So if you offer training, or if you offer, companies ask you, because it's becoming quite common, where that is their specific interest. Chad, how did that go for you the other day? You had mentioned you were going to call on a company where this was their primary concern, right? The seated worker, ergonomics of the seated worker. So
Yeah, so what Joe's referring to is we just made a contact in which companies asked me to come in and provide a bid for them because they're redoing some of their workspace. And so we're going to put a bid out to work with their employees to make sure that we are making sure they're set up in the right format to be as productive as possible. And not only as productive as possible, but obviously reducing the risk of injury. And so, and this is a service that you guys are going to face a lot out in practice. This is something that you can do to work directly with the employees and really have a really positive impact too. So we're looking at one division within this company of approximately 180 workstations. So it'll be a fairly reasonable sized contract to go through and spend anywhere from 20 to 40 minutes we anticipate with each individual and be compensated for our time. So it's exciting. This is really good information right here.
as mentioned, currently believe that about 70% of all work in America is done in the seated posture. Obviously, this represents millions and millions of workers. And since computer operators are the most prevalent in terms of occupational exposure, we will be focusing our message primarily on that component of the work population. However, as you would say, so this presentation will concentrate primarily on the ergonomic concerns of the computer operator. However, the information should hold valid for virtually any occupation where prolonged sitting is involved. So, we don't want to single out or exclude any occupational group, but this is what usually you'll be faced with. And so schematically it represents sort of like a checklist, right? The various things that you want to be sensitive about. And, we would refer to it then as sort of the optimal workstation environment. There's a couple of features on this that I probably would, like say for example, I'm going to suggest that the monitor is too close. Also, I would like to raise the monitor so that the eye level is in the upper 1/3 of the monitor screen. These are subtle. I mean, this is what NIOSH, I think this is right off a NIOSH website, and gives it as if this were the ideal. Also, I'd like to see that monitor the distance at fingertip reach. You shouldn't have a monitor closer than fingertip reach, and part of it is the EMFs, electromagnetic frequency issues, even though that's been claimed to be of little or no consequence. I'd say I would rather err on the side of caution, to not be as up close. It's like little kids sitting in front of a color television set playing their, all these video games all day long. Again, the manufacturers will say it's completely safe and whatever, but my thought process is that, like, looking at this more holistically. So I point that out in the sense that even though it's considered posturally, it's pretty good. I think, everything that I see here is relevant and I'm in agreement with, but except for those 2 points. The monitor should be raised a bit and also should be further away from the visual field. So most modern chairs, again, the title and the headline, begin with a chair. Go ahead, Don.
The bottom of that screen says something about a footstool. Is that been shown to show any benefit to actually raise the angle of the knee up higher?
No, it would only be for short people who can't touch the floor. We'll talk about that in a minute. But regular, no, the use of a footstool, unless you have a situation where you're not anchored, it's kind of like stability as well as the fatigue factor. If your legs are hanging, also it's going to be a compressive force for the returning venous circulation, the lymphatics and the veins. So if your legs are hanging over the edge of the chair, that could be problematic. So no, the footstool, if your height, now of course you could put them into higher heels, then this lady, as you can see, you know, hopefully she doesn't have to be walking very much because, of course, you know, looks like a good 4-inch heel. Obviously, let's hope that she doesn't have to be on a factory floor or whatever. Anyway, to address that point. So let's begin with the chair. So let's use that as our first state of taking a consideration of, so where do we begin in terms of addressing the ergonomic needs of the seated worker? Most modern chairs have been engineered to allow for mechanical adjustment to accommodate various body types. Chairs should be carefully evaluated for these features and full advantage taken of them. Workers will usually need brief training in understanding the chair's adjustability features. So I guess this would be an example of a typical modern office, what would be considered an ergonomic chair. Ergonomics from the standpoint is that it has a variety of adjustment capacity or adjustability capabilities, which obviously is desirable, but we want to make clear that this chair has actually a total of seven, shall we say, mechanical devices that allow for optimum adjustability of the chair. Now that's positive in the sense that it has capability of meeting the needs of a wide variety of individuals, different sizes, different needs and expectations and so on. It has, you can see, a nice lumbar cushion support. The first adjustment, though, that I want to bring out to point out these various factors is this adjustment feature. And then as you see, as we turn the chair, we've got 1, 2, 3, 4, 5, 6 separate adjustment levers that the average user, therefore, needs in many cases some instructions by. Then in addition, we have the capacity of the armrests to be adjusted for different anthropometric measurements of the upper extremity. So those are all desirable features, but the point that I really want to leave with you is the fact that there are literally dozens, if not many dozens, of manufacturers and styles and obviously prices and quality of chairs on the market today. Therefore, commonly as a consultant, you may be asked, for example, for recommendations to the employer if they're going to incorporate new chairs. My suggestion to you, doctors, is obviously this is often a very individual matter, and it's not an easy thing to accomplish. Certainly not that you can say, well, you're going to go to, shall we say, Steelcase or any of the popular chair manufacturers and suggest a certain model and a certain price range. The fact is that this can be more complex and very much like choosing pillows for people or bedding. Chairs are really no different, and therefore the workers, I think, should be engaged to some extent in the choice of if a firm, shall we say, a company is in the process of purchasing new chairs. My bottom line comment, though, with this short rendering of my comments regarding chairs and their helping the worker, make the proper adjustments, is that the doctor has to be familiar with these various adjustments on each individual chair. Some chairs only have 1 or 2, and others have 3 or 4. This happens to be the one that was provided to me, mainly because I asked when I became engaged here as an educator. They had a sensitivity for my perception of desirable ergonomic features. And so this chair was provided to me as the best one that they could find at the time. But I use it simply to serve as an example that there's a lot of subtlety in terms of helping the person to know the best adjustments for that particular chair that you'll be advising them on. So I'm hopeful that this little rendering is helpful to you understand that it's not a one-size-fits-all concept, and that chairs, just like any other personal item to be used, is not something that you can take casually. It has to be addressed with a certain level of professionalism. I'll stop it for a moment just to point out a couple of things in terms of these adjustment levers and what they do. For example, one of these levers allows the seat pan to go into lowered in the front, raised in the back, or raised in the front, lowered in the back. Another one allows it to go forward or backward. Let's see, there's about, like I said, there's more than is common. I mean, also to the point where it can be rather confusing and frustratingly so, to the point where the worker oftentimes just, plunks on it, and they may experiment with a variety of different applications of it, but in most cases, unless they've had a certain amount of introduction to what each piece does, they're going to ignore probably 3 out of the 7, maybe 4 out of the 7. There's some neat features of this chair, though. This feature is pretty critical, and it's referred to as a waterfall design, and that should have that soft edge, just as you can imagine, over like the falling water over a cliff, so to speak. Where that term came from has to do with the shape of the chair, and of course that's to prevent what we spoke of earlier, the issue of circulation. There's a consideration of the placement of the seat pan. This is referred to as the seat pan, and the depth of the seat pan is rather critical from the standpoint of this measurement from the length, literally then, of the femur. And what you want to make sure is that there's at least a 2-inch gap between the edge, even though waterfall in design, so that you don't have a compressive force on the vascularity behind the knee area. So in any case, as mentioned, sort of the bottom line message to what we're describing is that you, as the consultant, need to familiarize yourself with what you're advising the person on, and that would mean you would probably have to learn with them. You're going to an individual workstation, and you're going to take a look at what they're sitting on, and you're going to say, well, let's see how adjustable this device is, and then let's look at it together, and that kind of thing. You'll learn unless you have the time to do it beforehand, which then, if you're looking at, like Chad is talking about, 180 workers, do you think they will all have the exact same chair and the same style and features? Unlikely is my thought process about it. And Andrew might need a little assistance here in getting out of this. The escape button isn't responding to it. But in any case, someone has a hand. Gary? This particular one, I'm not certain, Gary. I don't use it. You'll see the one that I use. I worked as a consultant for a company. Oh yeah, I mean it probably is certainly on the higher end, and also I think they probably paid in the range of $500 to $600 for it, because the classic, really high-end chairs can go $1,200. Is not an outside range of what chairs are going for. But in a little while, I'll show you that chair that was given to me as part of my consulting arrangement with a designer. Maybe, John, you might remember it. It's pretty unique, but we'll get into that in a moment. But just exactly the name of that particular chair, I'm not sure, Gary, but we can take a look at it sometime if you stop by. Probably does have a little manufacturer's plate on it, But again, on the web, you guys, just imagine, there's just hundreds of choices. And in fact, I get calls pretty regularly from docs where they say, well, can you help me? I have a patient that's got this problem with sitting, and they got tailbone problems, and they got spine problems, and what do you recommend? Who's a good chair company? And like I said, it's kind of like trying to decide what kind of pillow people will enjoy. You guys have experienced that, right? Many of you have been making pillows available to your patients, but it's not as easy as it looks, right? Certainly not everybody can adapt to that contoured pillow and various styles and all the Tempur-Pedic and all these different things. So it's similar to this, and so I tell them to really sort of stay out of the business. Well, what I do, of course, is tell the doctor, encourage the person to work with their HR department, because that's the people who would be involved with this reasonable accommodation issue. And then usually what I recommend is get that HR person to suggest that they make their own choice to go to the web, look at all the different features. They may do that together. I mean, they're sitting and exploring the different kinds of features or options that are thought to be valuable. Then they find a local distributor of that particular one, or maybe 3 that they're going to choose from, and then let that dealer facilitate the responsibility of making that person happy. Because if you're the doctor trying to make that person happy, I'd say good luck. Again, it's a very individual kind of thing, and you don't really, you can't predict it. But I think that could work. And then also they usually, employers, if they do make a reasonable accommodation, they usually allow the person to have a lot of involvement with choosing it at the retail level, and then they can probably order it wholesale, whatever, work with the dealer to make it happen. Make what seems to be, and does it always work out? Probably not. Mainly because, again, it's still a device that has limitations. Go ahead, Don.
There is a company that is trying to make inroads and make relationships with chiropractic, and outfitted the ACA's offices in Washington, D.C. It's called Human Scale. They have displays, nice acrylic displays that they'll send to your office at no charge. It has their brochure in it, but it kind of describes a nice ergonomic chair and some of the troubles people have if their chair's not adjusted right. And they have a discount program that if you sign up with them, they'll give you an ID number, and you can write it on the back of your brochure. And if you give it to your patients, if they go to their website, then we get a discount. That's kind of their end. But they helped us do an ergonomic, helped Scott Bouch do an ergonomic webinar a couple months ago through the ACA. They're interested in chiropractic in Korea. So if you remember the name Human Scale, they seem to be pretty chiropractic friendly.
I appreciate your mentioning that, Don, and I've spoken with their principal as well, and they were obviously friends of my brother and Ergotron, and they have a lot of also really high quality ergonomic equipment, and in some measure they're a significant competitor to Ergotron. However, Ergotron never went into chair design or chair manufacture, mainly because there's extraordinary competition in that field, and my brother always felt that the margins were just not there. Much of their equipment, they were making a solid 20% profit, and if you can do that, in terms of the manufacturing world, a net 20% compared to 1 or 2 or 3% in the chair. So they just stayed away. They stayed out of the chair business. But Human Scale, I agree, represents a really fine product. So I'm glad that you mentioned this, Don, although we are pretty reluctant in these various training sessions to sound as if we're endorsing anything. But I would say, indeed, it's worth taking a careful look at. And of course, the neat advantage is that they're supportive of chiropractic, and they are a corporate member of the ACA. So I'd say in that regard, by all means, have it on your list of those to check out and take advantage of the opportunity of working with them. So styles of chairs, as we said, when we look at chairs, the typical conventional chair, to then, all of these various types and features, to then the less conventional, obviously, some a little bit far out, and I think many of you recognize this to be kind of an upgraded rendering of what they used to call the balance chair, BALENS, and it was a kneeling chair, and of course it had a certain level of popularity, kind of like, what was that shoe that didn't have heels? What was that called? The Earth shoe, I think. Remember that? You guys, some of the younger people may not even remember that. But again, these things go in fads, and the kneeling chair, the balance chair, was popular. What's replaced that in today's world is the ball, the inflatable ball, which we'll talk about in a moment. But the balance chair lost favor after a while because, of course, ultimately the stresses were overloading the knee joints. And so it's a sort of a trade-off kind of consideration. So, but that's what that represents. And the thing about the ball, while again, popular at the present time, and we see them a lot, quite frankly. In fact, there are some school districts that have incorporated this for children. And their consideration is that it allows them to fidget. And of course, the natural order, because, you know, there's the unconscious need to fidget. And kids especially want to fidget. I'm at issue with it, however, because I think it facilitates the loss of the lumbar arc. They don't sit on their ischiae. They sit forward, and I think it creates a abnormal postural situation for most kids. They, in fact, instead of slumping, they actually slump forward. That's what I've observed. And so if you are engaging with workers who believe that the ball is helpful to them and something that they like and they enjoy, what we recommend then, instead of the simple ball, is to engage in the ball concept, but with the backrest. And they are available as well. So again, is that necessarily going to be acceptable to all people? Perhaps not so. If you are disciplined enough to maintain your lumbar arc while on the ball, that's one thing. But again, the tendency, I think, is to let it slump backward, and you actually are reversing the lumbar arc and therefore setting up a pattern for problems. So, and this is the chair that I have and had involvement with the design of. And as you can see, it has this unique feature. It really is somewhat futuristic. The company is actually here in Minnesota. It's a great traditional chair. I mean, it's really well designed. It's about 8 years in the development of the prototype. And by the time it was essentially released to the marketplace, the recession hit. And the company never was able to mass produce it. Every single one was made by hand, and therefore expensive. It's about a $2,200 setup. Now the setup that's depicted here portrays just the chair, and in my office I've got a device. I touch the button, and the screen, the monitor screen, raises up, so you can put it at any adjustable position. Later we'll be talking about the sit-stand movement and this whole emphasis of getting the seated worker to spend a portion of their day in the standing posture and the desirability of doing that. What this does, and the advantage of over the typical stand, you know, where the option is to have the desk adjustable to raise up to having the monitor up here, keyboard down here, is the fact that the person is still bearing full weight on their lower limbs. So then you have the issues surrounding that, the fatigue of the legs and varicose vein issues and circulation, you know, issues, whatever. What's neat about this is that it's a supported standing position. You're essentially gaining the benefits of the vertical position. The neat thing, though, is that you can bear, you know, your feet can be bearing all of the load, or with a little touch of a button, you can settle back and, in fact, then bear a portion of the load on your knees, so it combines the balance chair. So you have the option of having a tripod, part of the weight on your feet, part of it on your knees, and part of it on the buttocks, if you will, the ischiae. And again, when you adjust the seat pan in relation to the back support, literally, for me, I can position myself right there, and I can do that for indefinite periods. It's the most comfortable seating system that I've ever seen. And if any of you have a hankering to want to, you know, walk upstairs with me after, I'd be glad to show it to you. I mean, you could, except that it's not available currently. I mean, there's some used ones on the market. If you're on the web, you can go to Health Postures, and it will still, I think you could probably get some used ones. And the reason that I mention that is that you may have patients who are seriously problematic with regard to coccygeal problems, or, you know, sacroiliac issues, or disc problems where they're precluded from prolonged sitting. And this can be a tremendous solution for them. Now, of course, most of them are currently in the standing mode, right? I mean, they'll sit for a half hour and stand for 1 hour, sit for 20 minutes and stand again for whatever. That's been sort of a solution. But I really like this concept, and I felt, you know, a good deal of closeness to the people. Actually, the original inventor and the designer is a quadriplegic, and that's where he got the idea of, because a quadriplegic, even though they have these apparatuses now that allow them to, stand erect at a sink and do dishes, for example. If you're in a wheelchair and you're in a typical modern home, well, it's not engineered for a person in a wheelchair, right? But if you have this gadget, this apparatus, and it can mechanically raise you up to, like counter level or whatever, there's a significant attraction and advantage. It became a very successful company for him, sufficient such that he could invest in this new concept. Their perception, he and the major designer, who was an ergonomist friend who used to work for Steelcase, and he also, Jack Hockenberry is his name, and he used to be a designer of aircraft cockpits as well, which is kind of curious in terms of moving from his younger career into now the world of ergonomics. But Jack and I did a lot of work on this in terms of diagrammatics, schematics, and whatever. My issue with these guys was that they perceived that this would be like a major breakthrough in the retail chair market. And my contention to them was not so likely in the early go. The price point was the biggest issue, and the other one, of course, is that if you see, here's what you encounter. So if a worker who has a special need, let's say a medical necessity, and therefore a reasonable accommodation, this is what I recommended that this company shoot for as the market. Don't try to go after the masses, right? Because the price points was the biggest single issue. And I said, if you try to go to the retail and with the idea of you have a bay of 60 workers and they're all working at their seated workstations, and so Sally gets one, and pretty soon, well, Joan says, well, how come I don't get one? And then pretty soon you've got the morale issues. So unless you're going to invest and provide them for everyone, the likelihood is that you're going to find resistance. And so that's really what they encountered, but I still think they would have had a reasonable growing market if they would have really focused on these individuals who have special needs, and then market it more in the realm of a medical device, if you will. In other words, a special needs kind of application in terms of seating. On the other hand, if you can pick one up and have an interest in it, I think you can still probably find them usually in a used market. So, and then talk about special needs. This is an actual chair, and I think you probably have some patients who would who would benefit from it. It's not something that you would expect would become necessary, but as we spoke of a little while ago in terms of the obesity issues in our culture, it has become a very unique situation. It's kind of like flying on an aircraft where they have to purchase 2 seats. It's becoming more and more prevalent, and even the first class seat may not accommodate a 480-pound person, but they're out there, as we well know. So we have to consider this idea of one size fits all, since virtually every chair manufacturer has its own approach to making the chair adjust to the individual worker's size, shape, and individual preferences. It's important for the consultant to clearly familiarize yourself with the different control levers and adjustment features of the chair to avoid embarrassment of yourself. But I'm saying, learn together, and there's no embarrassment in that. I mean, literally help Linda or Sally or Bill or Harry say, okay, let's try this, see what this does. Because they're going through the same thing, and I don't think you should feel awkward about that. Just go ahead, and it will be, I think, an interesting challenge to realize in a workplace how many styles and varieties, because they come in stages of purchase as the company grows, right? And usually a chair, a well-designed chair, will probably last, somewhat indefinitely, but at least 10 years, and then therefore the features of the chairs that were purchased back in the 80s or 90s, there's still a lot of those around. And so, but in the meantime, there's been a lot of improvements as well. So once you've gained this level of familiarity, there's a recommended set of steps to follow to arrive at the best solution to the given situation. So here we can now, once you kind of know what the chair's capability of, We would say adjust the vertical height of the seat pan so when the worker is sitting erect, his or her feet rest comfortably flat on the floor with their knees flexed at 90 degrees. That in part is to respond to your comment, Russ. Now, most seated workers prefer that the seat pan remain essentially level. You know, the idea of forward or backward, there's been some research on that, but much of it still will be based on personal preference. There's no hard data that says an incline, a forward incline slope, or in reverse would be advantageous one over the other. But some people have that preference, and part of it, I believe, might be related to the architecture of the lumbar spine. If you look at an anatomy book, you'd think that everybody has got a nice, predictable 35-degree sacral base angle, 35-degree lumbar arc angle, or a range of 35 to 45, a nice, beautiful. But in reality, folks, that's not true. Because in the studies that we've done when we did the original Viricon project, we kept track of that, and we found that 32%, I believe, it was in the early 32% of the people had sacral base angle in excess of 45 degrees, if you will, a hyperlordotic sacral base angle and or an increased lumbar arc angle. So put that in perspective then in terms of the lumbar support, right? So 1/3 of the population would have a hyperlordotic situation. 10% of the population had a flat back, meaning again sacral base angle decreased below 35 degrees, lumbar arc angle equally flatter than average. 10% had type 2 round back deformity, which is a unique configuration of an actual kyphosis in the lumbar spine. And then another small percent, like 1%, had a type 1 round back, kind of like a sway back situation. And then I think in our population, these are young people, 18 to 30-year-olds, they were, I'm thinking out loud for a moment, I think in the ratio of male to female, we have to put that in perspective when we talk about scoliosis, because as we know, scoliosis is more prevalent in females, right? The typical advancing scoliosis of adolescents, but in that population, we had something like 5 or 6% had scoliosis of more than 10 degrees, at which we started to consider that as a potential factor in the BSI scoring system, so to speak. So when you put that together, 56% of the population's spine is not like it is in a textbook. And I think those engineers, when they're designing chairs, they're still looking at textbooks. What they think the lumbar spine is, and I'm just saying to you and to remind us all that, hey, look, folks, they're not trained in what we're trained to realize. And to that end, I think it's a significant challenge on the part of chair design engineers, because again, they're not taking into account that half or more of the population does not fit the so-called stereotypical lumbar spine architecture. And until they do, I think you're going to encounter the same problem. So what have they done instead? Well, they have an adjustable lumbar support. Well, in some measure that can be helpful, but oftentimes that's an add-on, right, where the person has to like put a cushion back there or folded towels or some kind of a lumbar support mechanism. And of course, the chair in some cases is actually adjustable. How many of you have in your vehicle where you can adjust the lumbar support? A lot of the modern higher end automobiles have that. Sometimes it's even electronic. You push a button, you get a nice lumbar adjustment, so to speak. So most seated workers prefer that the seat pan remain level, as we mentioned, but they may require or find that for their unique circumstances, either a forward or backward inclination. But as I mentioned, probably has to do with the depth of their anteroposteral arc. The depth of the seat pan should be such that when the worker is sitting fully erect with the small of his or her back firmly positioned against the lower back support, the seat pan should extend far enough forward so that he or she can place the width of 3 or 4 fingers behind the upper calf and the lower leg. What I pointed out a moment ago, this will help prevent obstruction of the returning blood and lymph circulation of the lower limbs. And again, you'll find a lot of women where the femur, that anthropometric measurement, is shorter than you might have realized, and therefore they're sitting forward on the seat pan, not taking advantage of the lumbar support. You get the idea? Because obviously in order to prevent their legs from being crowded, they have to slide forward on that seat pan. So that's the issue that you have to be considerate of. So the third thing then, adjust the vertical height of the lumbar support so its maximum cushion thickness fits firmly into the worker's mid-lumbar spine. And for most people, if they are normally segmented, that's at usually the spinous of the third lumbar. That's the apex of the lumbar arc. They may have 4 lumbars though, and they may have 6 lumbars, right? Or they may have transitional vertebra. If you happen to know that about them, that might make a difference. But a lot of it is what they feel, their comfort zone. And of course you can kind of make a determination of that by a simple observation. But if the depth of the worker's forward lumbar arc is essentially normal, most modern office chairs will provide adequate spinal support. But as I said, that's about half of the population. For those with an exaggerated depth of their forward lumbar arc, an additional cushion may be required. Sometimes, though, these cushions are not in themselves thickness adjustable. So sometimes a person will prefer to bring something from home, and they'll just fit just the amount of thickness, because it can make a big difference. A half-inch difference may make a major difference for them. So you should encourage that, actually. For those who require an additional lumbar support, commercial lumbar cushions are available from various medical suppliers. Commercial varieties are portable, may also be used in the worker's car for additional lumbar support, but most people don't drag them along. They usually just get a separate one for their car. The one little feature about it, though, the one that's advertised most in our chiropractic magazines, I would tell you guys, flip it upside down. I mean, they've got the arc as if it's going to press right into the sacrum. You want to, when you flip it upside down from how it's depicted, then it'll fit into the lumbar spine. Again, I don't know who helped them with their design, but I think you know the one I'm talking about. It's in almost every single chiropractic, magazine, and if you look at it carefully and realize where they have the support is much too low. So, but it works almost perfectly if you would just invert it. So just take that for what it's worth. And then, of course, this is what we mentioned, the idea of encouraging the worker to place both feet flat on the floor. Shorter workers then would need the footrest. So that would be the idea of making sure that they have a comfort zone behind their legs. Teach the worker to avoid crossing their legs at the knees, as this places additional twist and torque, strain on the pelvis and the lumbar spine. Still creatures of habit, and many people find that that is their most comfortable position. Legs crossed at the knees. Men generally cross their legs with their foot and rest that way. Females, on the other hand, almost cross at the knees. What's acceptable, of course, is to cross at the ankles. But again, that's habit, and it takes a little change of long-standing pattern of behavior. And often, again, the patient has to be hurting pretty bad before they'll listen. You know what I'm getting at? Usually behavior modification. Keep that in mind, you guys. Much of what we're talking about this whole weekend, it really does require a certain level of buy-in. The patient really, or the worker, the management, all of these folks really have to have that sense of that they're actively participating in change. And of course, that requires behavior mod. And if you're really good at behavior mod, you should write a book on it, and you'll be a billionaire. Then you can contribute to chiropractic research. Because believe me, you guys, it's not easy, right? Behavioral modification is one of the most significant challenges in the helping community, right? How many doctors recommend people lose weight, quit smoking, and whatever, right? And then it's the issue of, do they really do it? Do they really follow through? It's like home exercises, right? Or people aren't, if they're not motivated, if they don't care enough about themselves, like we talked about, looking at there, they do this for you, don't do it for your employer. So you got to get their, shall we say, compatibility with their motivation, with what's in their best interest. Tough love, because it's, on their behalf, and if they interpret that what they are doing is on behalf of management, and therefore, their whole motivation is somehow to not think of it in terms of what they're doing for themselves. Obviously, you're going to have a great deal more resistance in terms of the behavioral mod challenge. So I'd like you to take the time to take a look at Dr. Scott Duncan. How many of you have read Scott's book called Sitting on the Job? It's a really fine, well-written book way back in the 1980s. He actually started the book the year that he practiced with me. Scott Duncan was a very unique individual in the fact that he's originally from Nebraska, went to Texas Chiropractic College, and he happened to be writing the boards here in Minnesota to obtain a Minnesota license. And the Board of Examiners had asked me to, I wasn't a member of the board, but they asked me to, they were short-staffed for some reason. One of the board people couldn't attend their testing module, and it had been, laid out, scheduled, and therefore they were locked into it, and so they had to have somebody that would help them conduct the exam. And so they asked me to take over the orthopedics portion of the exam. And so they said you can do whatever you wanted to, just make sure that these people are competent, they understand, the basics of orthopedic testing and evaluation, whatever. So I just dreamed up, put together a 20-question, profile, with the first question being the easiest, and then sequentially, and the most difficult question was the 20th question. And so once they got 10 correct, well, then they passed. They only needed to get 10 out of the 20, because once you got about number 12 and 13, pretty tough. But they only needed to get a couple of those bottom ones, right? Well, here's the Scott Duncan young man who comes through, and I couldn't skunk him. So I kept asking him even beyond the 20 questions, and he got every single one. I said, hey, this is pretty cool. And I asked Scott, well, what are your plans? He says, you want to come and practice in Minnesota? You're from Nebraska. And he says, yeah, kind of thinking of southern Minnesota. Well, I said, well, maybe you'd like to come and work with me. Because he was a gem, right? He was a pretty remarkable person in that regard, extraordinarily gifted human being. Anyway, what's kind of fun about this is that Scott recently was invited to do a TED Talk on sitting. And so do you know about TED Talk? Do you guys enjoy kind of some of that intellectual exchange by some of these world-class scientists and others who present on the TED Talks? And if you just Google it, Scott Duncan, it's called Sitting Fit, I believe. Oh, Sitting Smarter, Not Harder. I think that's what it is, whatever. Nonetheless, that in combination with his book, Sitting on the Job, could be a great and valuable resource for you. And I think Scott told me that, I don't know how they judge the so-called bestsellers, in the marketing world of books, especially in the realm of nonfiction type books, which become bestsellers for the fact that they're entertainment, right? But nonfiction and or business type related self-help books, I think Scott told me at one point, and this is probably 7, 8 years ago already, that he had already sold 150,000 of his Sitting on the Job books, which is kind of cool when you think of, it all started out when we were working together with in 1980. Might have been in 1980 was the year he practiced with me for 1 year, and then his wife, both of them from Nebraska, of course, they wanted to move back home. So he practices in Lincoln, Nebraska now, but he's really become a rather world-renowned expert and has helped with airline seat design, for example. He's worked with Carnegie Mellon in truck cab seating design, that kind of stuff. So Scott is really sort of a recognized authority on sitting. And we're grateful for that, obviously, because as a chiropractor, he's a great spokesperson. He's also currently working with Ergotron, the company that actually has made this weekend possible in the sense that it's through Ergotron that the funding became available for the establishment of the Sweary Center. And next time we're together, we can talk more about that, and we'll be able to tour where we are located on the campus here, and we'll get into that more. But I want to at least let you know a little bit about Scott's background, and also, if you're not familiar with it, it can be a tremendously valuable resource for this whole challenge. The question of armrests, most ergonomic chairs feature an armrest, and we do really encourage this. Remember how much the arms weigh? And we said again, individually, collectively, it's 7% of the body's mass, but holding the arm out in space without support over time is a significant fatigue factor. So both for shoulder and elbow and forearm disorders. Many well-designed ergonomic chairs then have armrests that are adjustable vertically, which you saw a moment ago on the chair in my office. Actually, my fancy chair that was from Health Postures, not only does the armrest adjust vertically, it also goes in and out medially and laterally, which I really appreciate the ability to rest it toward the midline. I can rest my forearm for certain applications on the computer. I do find that to be a nice feature.
You can buy his book on Amazon for $3.
Oh, Amazon, I used probably or whatever. Yeah, so that's kind of cool. That's sitting on the job. Yep. Yeah, right. So thanks for mentioning that, Scott, because that's right. There's a lot of really wonderful used information on Amazon as well, as we have all come to appreciate. So the adjustable vertical adjustment is a nice feature. Some chairs also feature this medial and lateral swing away of the armrest, which you should be looking for and perhaps recommend in certain situations when applicable as well. Then comes the desk, and the relationship of the chair to the desk is the next consideration in your checklist of how to go about managing the optimization of the seated worker in relation to their desk and their computer. So the top of the worker's desk should be about 2 inches lower than level with the worker's forearms and wrists when the elbows are flexed at 90 degrees and parallel with the trunk of the person's body while sitting erect in the chair. In other words, assuming the person's sitting in the chair and the arms are parallel, or the upper arm is parallel with the trunk and your forearms are extended, then the height of the desk should be approximately 2 inches lower than that. And a little bit later we'll talk about the keyboard in relation to that, but this is the position of the desk height. And then this business of this 95th percentile again. If the worker is unusually tall or short, it may be necessary to modify the legs of the desk. Well, that's pretty easy to raise it up, right? But to think of the desk and lowering it for shorter workers may be a bigger challenge, right? You can always find something to put under the legs to raise it up. But if you have a situation where you have to try to lower it, it can be it's a real challenge. So this could certainly require a certain amount of creativity in terms of retrofitting. Obviously, it will be easier to make accommodation for the very tall worker by inserting items of equal vertical dimension beneath the legs of the desk. Obviously, use of footrests for the appropriate heights for the very short person is another issue. Good morning, Brad. Welcome. So in those cases, like we mentioned, folks, almost every workplace, more than a dozen workers or so, has a building engineer. And as I said, almost always they're not a real engineer, but these folks can be tremendously helpful because they are used to finding creative ways to fix problems at the work site. So to assist in accommodation for unusually tall or unusually short workers, it may be practical to summon the services of the building engineer who can hopefully modify the height of the desk by increasing or decreasing its height to meet the recommendations that are required for individual workers. Part of the issue too, for all of us to reflect on when such modifications are made, that's well and good as long as this worker is the only person who's going to be using that desk. But of course, in modern work environments, frequently there are shift workers, right? So then you got second shift and then the third shift and you've got more than one person. So that's another challenge, right? Fortunately, I suppose statistically, most of the time, clerical workers, the majority of seated workers, usually shift work is not the case. But in manufacturing environments, when your primary job is to sit at a computer, that maybe the software is designed to cut metals, right? And you got a first shift, second shift. That's where you're going to encounter this more often. Because a lot of those applications in a modern manufacturing environment are computer-assisted systems that simply require monitoring, electronically, rather than what the workers used to have to do manually. So you'll have a lot of seated workers in a manufacturing environment as well. The next step is the positioning of the monitor. So the computer monitor should be positioned to be approximately the worker's arm or fingertip reach from where they're sitting. This is what we portrayed in that initial schematic. Remember, we said that screen was too close. So the general rule, not closer than. You can have it farther from you, that's okay, depending on, again, the font size, right, largely. And the other thing, of course, is your visual accommodation if you wear glasses. That's another issue which we'll be talking about, but the distance your screen is, in some measure, is proportionate to how large a font or how small a font is most desirable. But part of that is dependent on if you use glasses or don't use glasses to accommodate that. And this is the other item that I mentioned on that schematic that was shown to be ideal. We said that not really, because it showed her neutral visual was really right at the very top of the screen, and we're suggesting get it a couple inches higher than what was shown on that diagram. And you might need to tilt the screen for optimal postural comfort and elimination of the sources of reflected glare. I would mention, coincidentally, that was the very first invention that my brother patented. Back in those early days, he was a consultant, actually was the vice president of Sperry Rand Univac, but then when they wanted him to move his family to Philadelphia, he left Sperry Rand to become the reservations vice president for Northwest Airlines. And it was there that he observed all these reservations, all these ladies they were mostly women, but they were sitting at a fixed keyboard, and the monitor was down here, and the keyboard was fixed to the screen, so they were all flexing all the time, suffering just an incredible amount of neck and shoulder, arm, hand, headaches, and whatever. And of course, his observation with that was that we need to get that monitor up here, but then the keyboard is attached to it, right? So what do we have? Well, so he developed the very first application of an ergonomic consideration was a tilt-rotate mechanism that the monitor rested upon. And then, of course, as detachable keyboards came into being, well, then that was a tremendous solution. So of his 37 patents, that was the very, very first one to address this issue of adjustability of the monitor screen. And here again, this idea of, yes, you can do the measurement thing. You don't really need to, though, as I said, as long as you meet that standard of fingertip reach, probably is adequate. General rule, as we mentioned. And sometimes in the practical world, as we said, the $19.95 solution, sometimes, again, something as simple as a phone book, like these big urban goods, thick phone books have been a popular ergonomic intervention in many, many workplaces, folks. The last edition before the new one comes out, you have a good use for it. Don't throw them away. You might find a good use for it in the ergonomics of it. So many modern computer monitor stands have a vertical height adjustment. However, if unavailable, maybe need to prop it, and certainly something as simple as that outdated city phone book. So at the bottom line is this concept, right? You folks are practical people, and that's really what we're saying. Do what works, do what's inexpensive, do what's user-friendly and practical. So the next step is the keyboard, and the position of the keyboard is very important in the prevention of ergonomically related neuromusculoskeletal conditions. With the seated worker facing the monitor screen, allow his or her upper arms to remain in a neutral vertical position parallel with their torso, and their forearms and wrist positions at a 90 degrees. Again, neutral wrist, that's really what we're saying. Instead of having the keyboard tilting toward you, or sometimes a negative flow. For some individuals, they do prefer a slightly negative flow. In other words, where instead of the keyboard being perfectly level, slightly pointed away, generally to avoid having it tilted backward, because of course that forces the wrist into other than a neutral position. So usually we strive for the keyboard being slightly lower than the desk, and usually that allows, with the arms resting on an armrest, all of this remaining essentially at a neutral position. So the concept of 90 degrees from your trunk with the arms neutral at your sides, that's going to be the least fatiguing situation. If you have to physically hold your arms away from your trunk, that's going to be a fatigue factor, right? So you should allow the weight of your upper arm to simply rest in space with gravity, and then the forearm resting on a armrest, if you will, and then of course cushioned wrist rests as well. And then, so that's essentially the setup for the keyboard. So again, just below the worker's wrists and hands at a distance that does not exceed fingertip reach, while keeping the arms neutral at the trunk, elbows flexed at 90 degrees. Many modern desks that are designed for computer users, of course, have an adjustable keyboard holder mounted below the top of the desk. And a lot of times they're retrofitted because a lot of desks are old desks. I mean, quite frankly, desks usually don't wear out. They'll be desks 30 and 40 years old, but if you can, retrofit it to have a mechanism by which you can bring that keyboard, that's a very desirable solution, and there's a lot of those available commercially. And it does fulfill this need. And again, you literally should insist upon it. If you still are seeing workers with the keyboard up on their desk, that's going to put them into a jeopardized situation. So you clearly want to really insist on that. And as we said, a lot of desks can be retrofitted to adapt to that application. And then clearly, as you would know, in the years since the popularity of word processing, if you will, the generic term for what we do at computers, wide variety then of so-called ergonomically designed keyboards are currently available, each claiming notable advantage in reducing strain and fatigue within computer operation. One thing about this, while it's popular, and I've seen quite a bit of application of it. I mean, I've seen these, well, we'll give you an idea, these kinds of things, right? Lots of different, approaches to keyboard design and mice design, but there isn't much data supporting their advantage in terms of does it really help reduce problems for people. So put that in perspective. If the patient, the worker, however, right, well, some unique designs may actually accomplish various benefits. It's recommended that individual workers be given the opportunity to decide for themselves whether or not they would prefer that. And a lot of workers purchase them on their own, and management usually permits them to do that if they feel that it's advantageous, reduces their strain or stress. One caveat, as we reflected though, is again, one size does not fit all. So if the workers perceive that it's something that's mandated by management, we're going to discourage that again, right? You always want to engage the worker, make sure that they feel that it's in their interest to do it. So I would just use that as a caution. There was a great deal of interest in designing the mice and assuming that there would be notable advantage in reducing like carpal tunnel or various other wrist and forearm afflictions. Again, not much hard data that you know of, Chad. Again, it's usually individual preference is what I think has been the held view at this time. So, any comment on that, Chad?
Yeah, I think that the research that's out there, something hasn't been done in big numbers, so you're right.
Yeah. Certainly, there are differences in size of hands, right? And so, to that end, the size of the mouse and how it's held and activated and whatever, most of them are remote now, and usually they work really well. I mean, they're just amazingly more efficient than they were in the early days when you had to activate it with a wheel and various things. So, I think in modern times this is going to become less and less of an issue. We do recommend the wrist rest, as mentioned, the weight of the arm. And then if it isn't already a component of it, usually we suggest that it can be a simple, easy, inexpensive add-on, you know, the wrist rest. And sometimes it's completely detached from, you know, the keyboard, and or it may be mounted, you know, in front of the keyboard, and can be a really nice feature. So comment on that, Chad.
Yeah, just pops into my head here, Joe, that one of the things that we work with a lot of office people who do spend a fair bit of time with the mouse is you can oftentimes get them set up, and traditionally what you'll find is the key for being in a good position is to have the mouse close to them, right? But throughout their workday, invariably that mouse will travel to a further and further distance. And so by the end of the day, or even by halfway through their day, now they're reaching extensively, holding their arm at a full length to try to maneuver the mouse. And so we would highly encourage the resetting of that position often, because that will cause more shoulder, neck, upper back, cervical spine issues, is that completely extending that mouse arm. One of the biggest factors that I find when I go out to work on.
Any idea why they do that, Chad?
Well, I think over time what happens is after the workday, that mouse just gets a little further away. There's something that comes in the way of it, and it's moving a little further, and it's moving a little further. So oftentimes what we'll try to do is we'll intentionally put a barrier on the back side, so that as they're moving throughout their day, and in their work cycle, they're reaching out for it. So every time they reach out for it, if they move it,
they nudge it.
an extra inch further,
Yeah.
or they bump it a little.
Completely unconscious, right?
Correct.
Not even aware of it, right? Not realizing, of course, that they're adding stress. So, yeah.
What I've found as well is that a lot of keyboards have the 10 key on the far right as well, so the mouse gets put way out in right field.
Yeah.
So if they don't use the 10 key a lot, maybe recommend just get a basic keyboard, and then the mouse can be further in front of them.
That's really neat in the sense that all of these things are inexpensive now. You can just go anywhere and pick up a separate keyboard that meets your needs. I know my wife just got a new Mac, and it's got really narrow. I mean, I find that I have to know how to back on that keyboard. It's much too narrow, but it's really designed for a woman. And you know, she has smaller hands, and she loves it. I find myself, of course, now having to look at the keys, which on regular keyboards is not the issue, but it's a classic example of that. So,
Any thought on those yoke things that seeing they attach, and it's like a yoke?
oh, yeah. A support mechanism that way, yeah. Are you asking that as a question?
Anybody had success with
Okay.
use it?
I'm not certain that I can visualize what you're describing.
Sits on the
Platform, it's it attaches to the desk usually, clamps on, and it's like a two swivel arm, and then part of it has a yoke that rests.
Okay.
So they
Right.
this back and forth, but it's
I'd be a little bit concerned about whether or not it would obstruct the venous return again. I mean, literally the weight of the arm. These veins are very superficial, as we know. So if you're obstructing venous or lymphatic uphill, the transport of fluids. So I would wonder if it would be a mechanical insult at that level, whereas a rather, a flat surface forearm rest would be probably better, especially if it's a vertical height adjustment or internal, external. So I haven't seen that though. Maybe it does exist, and so. But I think I'd probably a word of caution about it. Go ahead, Gary.
Joe, is there a place on the internet, I thought I saw somewhere where you could get a picture of the optical workstation setup? You can actually get a picture, and it would be on a tear-off handout you could give to a patient to take home. I saw it at one time, I can't remember. Does anyone know about the resource?
If you were to, for example, Gary, you could just take this and write off the NIOSH website. That's where I obtained this one.
And just print it off.
But yeah, the one thing though, that when you're doing such things, I think if you're giving it away, but if you're selling it, you have to, I mean, if it's part of your, say the copyright issue is always an issue, so you can seek permission. So that's one little thing that, like as educators, we always have to be sensitive, like as an institutional setting. We can't just go ahead and casually assume that anything that's an image on the web is necessarily without copyright protection. That'd be my only issue with it, Gary, but you know, like a lot of this stuff is readily available.
I mean, I thought there was a company that had it in kind of a tablet form.
Probably. Maybe Chad, comment, because you had said that there's this private company that has all of this ergonomic information available.
Yeah, the Ergo Plus site really is more directed towards providing you the right information, and their stuff is copyrighted and comes that form. But again, I'll say that NIOSH has all of these guidelines, all these ergonomic guidelines, and if you're looking at something and their information is public domain, so NIOSH's website is a great source for that, and even the National Safety Council, their website provides resources that are public domain.
Wellness Councils of America is another group. You guys, I don't know if you've heard of them. They, you know, that's what they're all about: occupational wellness, you know, related sort of information site. Chad, are they nonprofit? You know, the wellness councils.
They're a member organization, and so they provide some resources to non-members.
Okay.
But the majority of their resources are for members. So
okay.
They provide some to the general public, but the vast majority of their stuff.
So probably copyrighted as well, though.
Right.
Yeah, unless you're a member, maybe you have access to it. So, but it's another group, and both. I think you've probably presented at their conferences, Chad. I think I've done 2 presentations at the Wellness Councils of America. That's what the name of their organization is. So it's another notable resource. Someone else had their hand. Go ahead.
Just very simple question, I think. What muscle group should be used to operate a mouse? What muscle group are we using in good ergonomics?
As mentioned a moment ago, Don, I think, you know, the vast majority of the work that we do in an office setting or on a word processing is the flexors. But the point we all have to realize, of course, every time we lift our fingers, see, when we compress, when we use force, you know, that would be a concentric load, right? And of course, when we lift the fingers off, and it's also quick, it's milliseconds, right? Then of course we're using our extensors, right? So I think it's you know, probably like almost equal amount of flexion and extension.
Well, a mouse, the only flexion is to push the button.
In most cases, yeah.
But you're moving it up and down and sideways. What muscle group? So we're using shoulders, aren't we?
Yeah. Combination, I think. I'm not quite sure where you're going with it, but
well, it's a very light. I mean, it causes lots of problems.
Yeah, repetitive.
And we work on. Well, the reason you came up is you know our colleague Dr. Robert Dubrow.
Yes.
California. He was helping me last year in Washington D.C. at the presented to the Student American Association about our specialty council, and I heard him talk. He said, you want to make sure your shoulder is working when you use the mouse, because ergonomically that you want the larger muscle groups working to operate the fine materials. And I thought, well, that's counter to what I ever thought. I don't want my shoulder working to operate this little 10-ounce item. But I was curious because he's got a lot of experience internationally in ergonomics and teaching. And I was curious what you thought, what muscle group are we using when we operate a mouse?
Yeah, I would not have included the shoulder girdle as very involved. I mean, minimally, I would say, but not purposefully. Not like, you know, with the goal and the notion that it's desirable to engage those big muscles. I think it's
more and more less ergonomics you're using, the more your shoulder muscle comes into play, of course.
Well, right.
That's why you want the elbow hanging at your side.
Right, neutral. Don't fire those muscles. There's no need to. No need to extend that or expend that energy to, you know, engage those large muscles. I think mostly we do it with our wrist. I mean, and just picture it, right? Think about it for a moment, just now. You know, obviously it's a very subtle, very, very minimal amount of motion that's required. So I'm not sure where he's coming from.
There is some forward and back of it, right? So that has to be shoulder to move the mouse up or down. So some shoulders involved, but we don't want the shoulder to have to bear the weight of the arm.
Correct.
Just to move that device. But I was curious if you thought about that.
Not really.
What muscle groups are we using? Because the mouse is a big headache for us, right? We work on a lot of people with neck and problems up here, and they do a lot, it's all mousing.
Yeah. Without question, it's repetitive, micro problem, right? I mean, it's really, a very, very subtle amount of movement, and you wouldn't think there would be a fatigue factor. But again, it's usually within a very small range of the same muscles, even though it doesn't look like it's work, hardly at all. Right?
The reason I ask is because a doctor's got a lot more experience than me.
Right.
Was telling student chiropractors that you need to use your shoulder a lot to use the mouse.
Chad, comment, feedback.
Yeah, it's from my experience that there is a fair bit of symptomatology that happens with our patients or employees in the shoulder region. But I believe it's because they're operating the mouse inappropriately. As I stated, that there's far too much reach, or they're not set up properly in their workstation, or because of their individual physical build. Somebody that has a wide physical build is going to end up using and engaging those shoulder muscles to a larger extent. And if we engage those large shoulder muscles for a continual time period, I believe that's where we have shoulder problems. And I would agree that our goal should be to minimize the amount of shoulder use involved.
I can hardly wait to talk with Dr. DeBro.
Because at that point, we're engaging the weight of the arm.
Yeah. So to that end, for all of us, right, as we said, it's a team effort. There may be some bases that I've heard of, though, done, and again, logically, I have questions. I have issue with it. I'm rather doubtful that would be a desirable objective. But next time I talk to Bob, I'll rattle his cage a little bit, because we go back a long ways, as you probably remember. Go ahead.
My only thought, if you do talk to him, it might be coming from as a golfer, they've tried to make the grip bigger for that purpose of using less small. So when you said to use larger muscles for smaller tasks or for finer tasks, that's kind of the idea. And I wonder if he's kind of pulling from that the idea of using, and that's why they've made the grip on a putter larger, and there's less variance because you're using a larger muscle group. So that's, when you said that's the only thought I have.
Yeah. Well, won't it be fun when we encounter your colleague?
I think no matter what accommodations you make, a lot of people, I'm doing it here, I sit this way, when I fatigue there, I use a different muscle group. When that fatigues, I'll use a different muscle group. So, having a general maximum comfort level, and then, I think people tend to,
Exactly.
so, to have variability or self-adjustability by the.
So much of what they're doing is unconscious. I mean, they're engaged out here. Their concentration is not certainly on how they're sitting or how they're using their body part. And what do we call that, you guys? I mean, what is the required end objective in this? It's called, remember? It's called right? We've got to create new neural pathways, right? It'll always follow the path of least resistance, and that's what we do unconsciously. It's like you don't remember tying your shoes this morning. You did it unconsciously, right? Or many of those activities that we do. So that's really the issue. If we can kind of get into this. And the beautiful thing is, of course, now we know about the fact that the brain literally will remodel itself. And again, what you use, you will gain more of. What you don't use, you will lose. And the brain loses tissue, loses actual, cells, but you gain new ones based on new patterns. So if you can condition that individual to start to realize that neuroplasticity is really going to be our friend, but it also requires then this concentration of shifting the old way for the new way. The language, again, that Dr. Schaefer uses in his spine injury prevention training. He talks about the old way or the new way, and then getting people to appreciate the value of the new way, and then to get them to choose that behavioral modification element in the equation. So let's take a break, you guys, and then we'll come back and we'll complete the session. Roger Sperry, some of you may have heard of him. He was a Nobel laureate, and his contention from his own studies was that 70% of human energy is expended in simply maintaining the body's mass in space, or moving it through space. So think about that for a moment, folks, in terms of how then we maintain our body's mass in space or move it through space. The efficiency of that is a real critical issue, and that's what we're asking you to think about in terms of the, say, the seated worker who is in a static posture for hours and hours on end. So to that end, I've tried really hard to find the actual reference to this. Several people have noted it in their publications, but when I go to their reference on Roger Sperry, Nobel laureate, specifically citing this in one of his published pieces, I've not been able to find it. So I say it's attributed to him, and he may then have made reference to that in an oral sort of presentation somewhere in an unpublished rendering, but it's still provocative when you think of that reality. On the other hand, moving the body through space, as we know, requires a great deal of energy. So, it's kind of like an automobile. If it just, sits running, you can, like simply idling, that's one issue. But then if you put it on a treadmill, like a vehicle, like they do in a testing environment in the car manufacturing facilities, they probably get 800 miles per gallon, right? Because there's no wind resistance. You get the idea? So part of what we're talking about here is like, there are many, many elements as it relates to moving the body's mass through space. So then this equation becomes reasonable, right? 70% of energy is required by moving, the effort to move the body's mass through space. So thinking about it in that light, I think it's realistic. And then, as we mentioned, I believe that our innate inborn wisdom would suggest that we're pre-programmed, we're hardwired to conserve energy. I think it's just common sense that we don't burn energy unnecessarily. Of course, when we do, it's called exercise, right? So we can intentionally, burn more energy than is required. Obviously, we call it sport or recreation or exercise. So that's another thing to think about. But this need to survive based on this, as we said, in terms of rest is critical. Sleep is required for, perception, the preservation of life. So we're going to think about that, but clearly when we consider the fatigue response, the body's desire to conserve energy then kicks in big time. And I think that's what we're talking about. That 3rd hour, 4th hour, 6th hour, 8th hour, 10th hour, in a static position, that's when the fatigue factor. So to that end then, we have to think in terms of how can we facilitate the worker in that seated environment requiring the least possible expenditure of energy is really what our goal is. And we're perceiving then, as we said, that the most efficient way to do that is keep the weight of the head superimposed over the midline, in essence, right? Optimally positioned over the shoulder, reminding you again of that anthropometric data, that 7% of the body's mass. We pointed out again, 140-pound person. Their head would weigh approximately 10 pounds, and a 200-pound person, 14 pounds is a lot of body mass to hold in space. And again, you've probably seen the little demonstration with the bowling ball. Put your fingers into a bowling ball. As long as you hold it supported right over, somewhere down here, you could probably hold it for an hour. Probably wouldn't enjoy it, but let that bowling ball go out here for even 5 minutes and you probably are going to sink, right? It's not capable. So that's the logic of it. And frequently this is an easy way to demonstrate it with your patient as well. I didn't have a bowling ball at my practice, but you can visualize it, you can verbalize and help them to understand that. And of course, we all are appreciative of the support mechanism that allows this to happen. And of course, these are the tissues that are vulnerable then, right? Upon overuse or, when the mechanism fails. So what are we basically saying is that when you offend this principle, you put at risk then the vertebral bodies. Obviously, they can adapt, and we call that Wolff's Law. And of course, there's another name for that, and it's called spurs, right? And therefore, it's like a hypertrophic change that we think of as abnormal, but of course, it's simply Wolff's Law, deposition of minerals. So if you continually hold your head forward of gravity over time, you're going to develop a degenerative change And of course, coincidental with that, it's going to change the shape of the bone. So that is put at risk. The discs, the network of ligaments, cartilage, joint cap, all of these things, and the counterbalancing muscles, both flexors, extensors, and of course, rotators and lateral flexors on either side as well, are all vulnerable when we deviate from this conceptual model, what we would call the idea of loading in the most efficient manner, what is often referred to as the neutral posture. So the head is centered over the midline when viewed from either the AP or the lateral plane. Some ergonomists feel that a forward incline of the head, but not to exceed 5 degrees, may be acceptable. I think partly because of common usage. I mean, it's like, it's almost awkward for many, many people to hold their head. It's their natural inclination, and therefore they may say it's an acceptable range. Not maybe optimal, but an acceptable range. Okay, it's kind of like a lot of things that are not, like 100%. Places the smallest demand on the energy expenditure, results therefore in the least amount of physical stress and fatigue. That's the basic assumption. Again, notion of what we call a conceptual model of an optimal arrangement. Static work postures requiring a shift of the head away from this neutral posture, either bent forward, backward, tilted, or rotated to either side, result in an unbalanced asymmetrical muscle loading. When this is experienced for prolonged periods, obviously there's a buildup of toxic waste products, as you guys are also very familiar with, and of course with that whole realm of soft tissue afflictions that have very popular names, from myofascial fibrositis to ultimately, more collectively now, all of these soft tissue syndromes. A consideration, I guess, within this whole phenomenon, think for a minute back now to yesterday when we showed those x-rays. Did you see that? Do you think that's volitional? Do you think the person, if they wanted to, could level out that disc? I don't think so, you guys, right? Do you get where I'm going? I mean, like I say, this is what we would prefer. The weight of the head, balanced, right? Symmetrically balanced in both planes over its base of support. But what if T3 is sitting this way? And then C2 is sitting this way, right? Because it's an effort to counterbalance. Well, that means that, try as you might, right? Try to, get the patient to be as, like within this conceptual model. I'm saying a lot of it is not volitional, not where they can voluntarily change it. It's like saying, Johnny, come on, you can straighten out those teeth. Try a little harder. Just straighten them out. You can do it. You can do it. I'm saying, no, not in the subluxated spine, where the disc is deformed. You get where I'm going? You may have a vectoring, a shift of the body's head, 1 to 2 inches away from the midline. A couple of considerations in this, you guys. If a person is blind in one eye, right, or have significant loss of vision in one eye, even in not total blindness, but let's say it's a dysfunctional eye or a lazy eye, what might that do to this formula, this conceptual model? What do we need to do? We have to have peripheral vision, right, especially for driving. So what do these people do? They have a dominant eye, and they will therefore unconsciously have that neural pathway. That's their normal. But of course they're chronically subluxating, or they're chronically causing an asymmetrical loading pattern, right? Interestingly, this would also be true for people who are deaf in one ear, or have a classic loss of hearing in one ear. Similarly, right, we will have a dominant ear, and it'll affect our total gross posture. And of course you can verify this when you start looking at people in a plumb line. When you just start to look at them in terms of where they are in relation to the force of gravity. So just kind of keep that in mind, and part of your history, or part of your gathering of information when you're setting up that work site or that workstation for this seated worker. Ask them about that in terms, do you enjoy equal bilateral vision, or do you have lenses that allow for equal, visual capacity and so on? Because if they have this unique situation, or if you notice that they're cross-eyed, right, well then you know right away that you're not going to accomplish this, certainly not effectively or efficiently. So just kind of think about those elements as we, consider it. And as we said in this situation. This is what I believe occurs with many people sitting on the ball. This whole idea of letting the lumbar spine go into a kyphotic presentation because they're sitting down on their coccyx. I mean, they're letting the whole pelvic slope is undergone a reverse from the ischial sitting. When you see Dr. Donkin's sitting smarter, not harder, he talks about what he calls the pivot point, and he literally has people sit on the forward portion of their ischii. I mean, it literally anchors them into this, and it kind of is a really fascinating consideration. Of course, knowing me, I challenge Scott and say, well, what about the person, though, who's got, you know, a 70-degree sacral base angle compared to a 20-degree sacral base angle? Isn't that going to make a difference? Again, Scott, you're telling people everybody should sit this way, right? Like there's an absolute point at which it's optimal. I'm going to say, maybe not, Scott. Maybe you ought to reconsider for a minute and realize that, hey, it may well be different for different people. Because, you know, I mean, much of that architecture is based on, like, say, what are the determinants of the lumbar arc? You really have three variables, right? You've got the shape of the vertebral body, that's bone. And in the adult, is that likely to be remodeled? Remember, that's usually taller in the front, shallower in the rear. So if you've got L5, L4, and L3 are all much taller in the front, what do you automatically have? A deeper lumbar arc, but it's bony, right? What's the second variable? Well, the disc angle, right? The interdiscal angle may be normal, 10 to 15 degrees, let's say, slightly narrower in the posterior. And so that's another variable. It has some elasticity. We don't know exactly how stiff the healthy disc really is, which is a fascinating area for future research because we're currently looking at that in our research discussion group. We have an advisory board that sits in some feedback, a dialogue with the people on our research team, if you will. So what's the final variable in determining the lumbar arc? Well, yeah, but those are volitional. See, that's the whole point about it. Everybody says it's muscular. And again, Jerry, you can straighten out if you really wanted to. I'm saying, no, what if your facets are at 60 degrees? Your facet angles are bony. You can try as you might, folks. You're not going to change that. Neither are you going to change the shape of the vertebral body. Am I making sense? So all of this comes into this picture in terms of it's very individual. It's very individual, and therefore you have to be, at least have that in the equation. Like we say, the person with a lazy eye. That's not your common experience, and you say half the people fall into this so-called normal range of lumbar curvature, but you got to know there's a lot of considerations in the picture, and if you think you can exercise it away, it's another it's a deception. You've got to sway back. Let's tighten up those abdominals. And hey, folks, you shouldn't be giving that advice until you've got some radiographic evidence and you really know what the architect is. Go ahead.
If they've got a spondy, that's good.
That's another example, right?
You don't want somebody hyperlordotic and they've got a grade 2 spondy.
Correct. So, again, it's an architectural thing that we have to be sensitive about. And therefore, we can say that there is a certain amount of the information that can be generically shared with people, right? But recognize that within that, there are limitations. And it may not be accurate for that individual. We can say this conceptual model may fit for many people, but there are clearly reasons why it might not work very well. And so you have to be tolerant of that. And but I'm going to suggest that the notion here of preserving the original arcs would be the most desirable arrangement, we believe, in terms of preserving and maximizing the efficiency of this mechanism. Go ahead, Chad.
Yeah, Joe, I just want to further emphasize the point that you're making, because I think that this is one that we can't miss as potential consultants out there. Anybody can go out on the internet right now and find out the exact proper way to sit and how high the computer monitor would be, and many of the safety personnel, the human resource personnel that you'll be dealing with have that ability, have that knowledge, and maybe even have had that sort of level of training. The unique thing that we bring to the table and where our value is as a healthcare provider and taking in those individual needs that Joe is going through and translating that into how best to be able to set that employee up. If the lumbar spine is not the right, our sacral base angle is off, or maybe we've had a whiplash type injury from an automobile accident, and now we've got to accommodate the fact that we might have a reversal of the cervical curve in that individual patient. And that's what companies should be willing to pay us for. We should not be out there trying to market our services as an ergonomist, because that training can be done by many people, and already is. Our specialty and what you can offer to companies is to be able to understand physically what that employee's condition is and how best to be able to put them in their work environment. Yeah. I think it's the single strongest factor we have when we go out to talk with companies upon why they should bring us in to work for them.
Good counsel, Chad. Thank you. This is where I mentioned again Dr. Donkin's TED Talk. 13 minutes in length, and it's entertaining. It's very well done, as you would expect it to be, because that's a pretty sophisticated news media, facilitating thing. Honestly, I called Scott last night to ask him whether or not we would have permission to just go on the web and play it. But again, it's kind of sensitive. You see that the sponsors of TED Talks may own the copyright, and that was the point I was going to, even though Scott is saying, well, you can use this for patient education and whatever, this educational event, of course, is a marketable commodity. In other words, the school will be selling doctors, purchasing this training, okay? Therefore, we have to be more sensitive. It makes sense. I'll just encourage you to go online, though, and take a look. You'll find it to be, really interesting, and certainly, I think, has a lot to offer. But as I said, there may well be exceptions to finding that specific point that he's recommending. In addition, abnormal work postures produce asymmetrical compression on discs and excessive mechanical loading stress on supportive ligaments over time. These loading forces contribute to the development of degenerative disc disease and result in pathologic consequences. And where and how this comes, well, we'll get into that in a moment. Position most used, objects such as phones, staplers, paper clips, tissues, appointment books, pens and pencils, all this stuff that you use on a regular or an hourly basis should be, of course, within the easiest reach. It's kind of like this diagram, kind of, pretty common sense. The notion, of course, is to eliminate or minimize this excessive reaching, what you were talking about a moment ago, Chad, with that. I can see it now. I didn't really think about it much before, but I think there is this unconscious thing that the mouse gets further and further away from you at the end of the day, and you don't even, I'd never really realized that before, so thank you for sharing that, Chad, because that's going to definitely create a different set of mechanical forces or stresses to that individual. And of course, all of this is still within fingertip reach, right? Doesn't require a forced flexion load moment creation, right? So that's a secondary zone. But if you have things that are beyond that, well, then of course you're adding the potential for additional stress, which of course then would say, I'd recommend, for example, keep those objects far enough away from the desk so they have to physically get up and get them. Like say filing cabinet where you're retrieving files. Because what are they going to do? They're going to twist, and they're going to reach, and they're going to find and get into that file, right? We're going to say, hey, wait, put it far enough away so they have to get up, move, right? Because that's the whole idea of we want to get at least on a 30-minute, optimally 30 minutes, every 30 minutes, get up, move about, right? Do a little stretch, do a little dance, whatever you need to do to sustain some mobility during the workday. And this would be one example of what would be a way in which you can facilitate that. Those things that they can't immediately, easily access, place them far enough away so that they have to get up and move to retrieve them. So, and this image is kind of like, well, what are the varying factors? Now this, for example, shows the monitor screen at that fingertip reach. That's probably better. Eye level, notice again at the upper 1/3 of the screen. So this diagrammatically or schematically represents a more desirable set of sort of, relationships. They had, superimposed over the shoulder. And of course, this distance, we've got that 2-3 inches of space. It could show a little bit more of a waterfall edge on that chair. Also, of course, there's still a few old office chairs around that only have 4 instead of 5 of the wheels. They're, of course, much more risky in terms of basic danger. Feet flat on the floor. As you can see, the keyboard is, positioned lower than. You can see at elbow height, the desk is about 2 inches lower. These are the basic rules we just verbalized, right? So here again, it's schematically represented, and it's like a checklist. Have I covered this? Have I covered that? And whatever. So brings the next topic into this issue of eye strain and how common is it? Well, I think probably not a person in this room hasn't experienced some of it. If you've been like most of us, you spend a fairly, well, field doctors probably not nearly as much as people in education or other fields, but I know I'm at my computer at least 7 hours a day. I don't think there's ever a day goes by that and then some at home after I get home. So it's easily 7 to 8 and 9 hours a day. And of course, we all need to sort of follow our own advice, right? How much do we get concentrating on getting the task done? And now we're 2 hours into it and we haven't moved. We haven't gotten up and moved. What motivates me is I'm a water drinker, and that means I got to go to the bathroom. You get the idea? That's part of a secondary benefit of being a person who consumes a fair bit of water, because of course that means you got more frequent need to go to relieve yourself. So, it seems like it's an indirect means by which you accomplish the same objective, right? Get you moving, get it going. So how do we prevent eye strain? Room lighting, of course, is significant. The basic rule, again, time-honored rule. This is almost never, I've never almost ever observed this in the real workplace, but this is a recommendation. The computer screen should be the brightest object in the room. Well, one would say, but how about all my other work that I have to do? Well, most of the time you're not doing that other work, right? You can diminish your overhead lighting and all this other stuff. So if this rule were to be followed, it would dramatically reduce this potential for eye strain. So dimming the overhead lights will reduce the glare and help prevent eye strain. Task lights, and preferably not fluorescent overhead lights, but task lights, preferably incandescent, as we stated, strategically placed on the worker's reference material, can be, very useful, very helpful. Most of the time at our computers, though, we're composing. We're not, unless you're in a work environment where you're a person entering data day after day, hour after hour. Many people are sort of expected to do that. That's when this would come into its application more commonly. So, but for most of us, usually it's not required. So in terms of reducing the screen glare then, adjust the lighting of the screen brightness to just dark enough so that you have to slightly strain to read the text on the screen. You all have adjustable, backlighting behind your characters on your screen, right? So you can adjust that, darken it to the degree that you can hardly see the words, and then though bring the light back up so that it has this perception of a soft effect. That's what is recommended in terms of, again, the strategy to help reduce eye strain. And then the next thing is, of course, reflected glare on the screen surface. So position the worker's monitor so any possible reflected glare from nearby windows, glass-covered pictures, mirrors, overhead lights, and other sources of light is eliminated. And this step for a lot of people is a surprise. White or light-colored blouses and shirts result in more glare off the screen. So it's best to use dark-colored clothing when working on the computer. Again, it's a very subtle thing, right? You wouldn't think that it would have a bearing, but you can understand that it's like a mirror effect, and so you're looking into that all day long. Then if glare is an issue that cannot be overcome from the above recommendations, then usually there are still anti-glare filters on older monitors now. They come with it. almost none of the current monitors require a filter because they're built in at the current time, so not a concern. They look like happy workers, right? They look like they're, having fun at their work site, but what does this suggest, you guys? I think there's a significant amount of glare, right? You're getting a direct bounce back, and I don't see any shades. I mean, there's probably shades, but maybe not. A lot of these modern office buildings that are up several floors, they don't need, there's no privacy issues other than low-flying helicopters maybe, or whatever. Bottom line, therefore, is that there may not be shades or screens or any kinds of means of obliterating that glare source. So, and of course, they're going to be getting that bounce back, all the time. So, here's an example of it. See this glare on that, probably a type of granite surface is an example of what's going to be showing on their screen. So. And then we recommend strongly every 10 minutes or so the workers should turn their visual focus away from the screen and onto an object or view off in a distance, even if they're looking at the wall, because of course, as we know, when we look at the screen, our pupil is constricted to an exact point. It's a constant, and of course, therefore, our pupil is being held, and that's of course just like any other static loading, right? If you hold your body part, just try to hold your arm out, pretty soon so the same thing is true here. All you want to do is have the ability to let your pupil expand and contract. And you do that by focusing. But they can't just daydream focus. They have to focus on, say, the seam in the cement blocks. Not just seeing the wall blandly. You're focusing. So now your pupil actually focuses on an object at a distance. That's what you have to help the patient to understand the difference. And then regularly shifting the gaze in this ways will allow the pupillary muscles to finally relax, prevent the buildup of static loading, which is that whole idea, this idea of why we need to do this, right? You all have experienced it, right? How good that feels. And what are you really doing? You're mobilizing waste product, right? You're getting rid of that buildup of toxic material. A copy holder, again, can help prevent neck strain, and obviously it should be positioned either to the right or the left. But it should be at the same vertical eye level as the monitor. So if mounted to the right or the left, and I generally recommend that it be shifted from day by day, so that you're not constantly looking to your left. If you're using, your data source that you're copying from, or so. Obviously, again, the notion is to shift that. Best to move the device to the opposite side of the monitor on alternate days. Again, that's a behavioral mod, right? Is it likely to occur? The likelihood of compliance could well be an issue here. Most people won't simply take the time to do it, thinking, it's so innocuous, that's no big deal. It's only a 15-degree difference at the tilt of my head, but just start doing the math and doing that, the number of hours you're holding your head in that position. And then over time, of course, it's a cumulative thing. So the notion is, of course, we want to try to sustain a balanced use of the neck musculature. One of the reminders here, again, is if you have kids that are in swimming, swim coaches are still letting, the whole breathing thing is always over one shoulder. I try to use that. And I say, because several of our kids were in swimming, I said, now, you're doing your laps, get rhythmic and go left, go right, But it's like, they always over that left shoulder. I mean, you see that pattern, swimmers will do that. But think about it, right? It's the same idea here, you guys. It's something that is programmed, and pretty soon it becomes habitual. We get habituated, and pretty soon that's your neural response, right? And it'll follow the path of least resistance. And then it's difficult to overcome. So when we were kids, literally on the farm, my dad, from the old country, I thought he was pretty savvy. And he literally taught us how to shovel, literally, whatever we were, hay or, gravel or manure or whatever. I mean, he literally, he would bark at us, to do it the other way and then do it the other way. So again, this is part of our consciousness from childhood on. And I really respected that because I, normally would not have anticipated my father, coming from the old country, to have that savvy, if you will, and made a lot of good sense. And some people, if they use a copy holder, like to have it right in a position right below their screen so that they just go vertical up and down instead of side to side. And maybe that's an option for some types, although most of these monitor mechanisms may not permit the space of that, but nonetheless it's an option to consider. Now this is another extraordinarily important consideration, especially in dealing with, if you think about this for a moment, right? Eyeglasses, contact lenses, ascertain that they have the correct prescription for the distance he or she is positioned from the monitor. Okay, if it's learned that the lenses and the distances are not optimal, the worker may move. Now this is one option, as we mentioned earlier. One of the reasons why you might want to move your monitor further away, simply because your focus, is easier with the glasses that you currently are using. On the other hand, usually the great concern that we have is for when people have bifocals or trifocals. And as you can imagine, right, especially in what age groups, when our vision starts to fail, right? So when our lenses start to harden, and for many of us already from, in our current culture, we are extraordinarily visually oriented, right? Our children grow up with, in terms of how we perceive information, in terms of the learning model, or even in the model of a teaching experience. And as you know, the word doctor means teacher, right? So in terms of your ability to convey information, like say at the work site, if you're giving health-related talks and whatever, you have three basic modes of doing that. What we are doing right now is called the auditory response, right? But because culture is so oriented toward the visual, we provide you both, right? We give you we give you a combination of auditory signal and a visual signal. And then what is the third mode of learning, if you will, or conveying information? What would that be, and how critical is it? It's called the kinesthetic, right? Or the hands-on component, right? That's partly where you engage the person. I mean, literally, they have to physically get in the chair. You can't just verbalize it. You have to sit in it. You have to experience it. You have to get the tactile or the kinesthetic component. So putting that into perspective, when we go through these teaching modes, you have to kind of, realize that the consideration here having to do with the use of bifocal and trifocal, what is the relationship? Obviously, for some individuals then, their best practical thing is to have their optometrist or their eye doctor, whomever it may be, fit them with the lens that's specifically for this distance so that they may be able to forego the need for use of bi or trifocals. They have just the lens that's kept at their workstation, or if they have a computer at home as well. Bottom line then, that would be one of the recommendations. The biggest concern, of course, is, as you would see, bifocal, trifocal lenses are prescribed usually between the 4th and 5th decades of life. As we mentioned earlier, because our youth are now becoming so profoundly visually stimulated, we think this is going to occur earlier. The lens will start to thicken and harden probably in the 30s. I know of young people already that they need reading glasses at age 34. And in my era, it was probably more closer to 40 to 50, which is what we're talking about here. But what's coincidental about this, so you guys? By that time, half of all adults are going to have already measurable discogenic disease in the cervical spine. So now when you come home or you go to work with your brand new glasses, you never needed bifocals before, but now you do. But in order for that particular component of the lens to see clearly on the screen, what are you going to have to do? You're going to have to tilt your head, and that then can provoke a whole storm of symptomatic reaction to arthritic cervical spine, right? And of course, that's only one category of it, because obviously we have post-traumatic cervical injury residuals, right? And that's really, really common for people who have had particularly whiplash-type trauma or concussive forces, which obviously can leave damage. And so this can be a real critical, you might say that patient comes in now, age 46 years old, and they never really suffered headaches before. And if you're astute, one of the first questions, do you work at a computer? Oh, I sure do. I say, well, have you gotten new glasses lately? Right? I mean, this sequence of questions has to be now part of your repertoire, right? You can't ignore this, is what we're saying. This is a really common, typical kind of experience. And so it may not be necessarily headache. It may be then maybe shoulder, arm, hand, or brachial symptoms that they never had before. So just one more little, it seems like a simple concept, but it's one that could be really important. And again, near vision lenses for viewing the computer screen, so we want to really make sure that the worker has an ability to maintain their optimal neutral head posture without sacrificing their vision. And so this is how we might go about that. And of course, we recommend that people actively do eye exercises, obviously 10 minutes or so. They should look to the right and their left and up and down, and again, just with their eyes, not with their neck. I mean, they can and they should do it with their neck too, but part of it also is to hold their head neutral and then look, just use these other muscles because they're constantly holding the, the head in the visual field in a static mode. So not only the pupils, also the ocular motor muscles, right? So think about that, and that would be the logic of it. And then we also suggest having the worker close their eyes tightly for a few seconds, let them relax while closed. So it's like tightly hold your eyes as if, instead of just closing your eyes, we're saying, tightly close your eyes and then force that for a few seconds, then release it and then do it again. Again, what are you doing? You're pumping or mobilizing those waste products. Another simple way to do it. And then also, of course, having your eyes closed allows your pupil to dilate, right? Which would be a desirable thing for simply holding their eyes closed in a relaxed mode for a few seconds, 20 seconds, whatever, gives them a few moments of rest time. Could be an important component. And then this one, as you saw in the fellow earlier on that image, you kind of take a clue from babies. Little babies, when they're tired, you will often see little babies, well, literally, they'll just be digging in their eyes with their little fist. That's an unconscious reaction, and of course, a good idea for you as well. The eye is a lot less fragile than you might think. I mean, when you describe this to the patient, they might say, oh my goodness, I don't want to hurt my eyes. Well, if your eyes are closed, your lid protects it, and you can get in there pretty deeply and vigorously, do that massage. Feels great, and it accomplishes this really nice sense of. One little caveat there is a lot of women use a lot of eyeshadow. They have makeup, and that then can, be an irritant. It can be an irritant, gets in the eyes. So you have to put that in perspective, but nonetheless, simply an easy maneuver. Mini breaks and micro breaks, obviously to get up every, it says take 2-minute breaks from their computer every half hour. Get up, move about, stretch, extend their fingers and wrists, roll their head, neck and shoulders. What did we say a little bit earlier? This might be a great time to do this maneuver, right? Put stretch to those flexor muscles and really give it a good tug so they feel it in here. Do it a time or two. The micro break, this is where they remain seated. Actually, they stay at their workstation, but here they can do deep breathing, head, neck, and shoulder rolls, arching of their lower spine forward and backward. Simple movements like this will help the body rid itself of these end products of muscle metabolism, again, avoiding the effects of static loading. So pretty straightforward. This is an entire separate category that's somewhat new in the last, how long have laptops been around? 10 years, maybe a little bit less, right? But what's your thought about it, you guys? Is this, I perceive it to be in some measure, almost an epidemic to yet manifest itself, simply because, as you can imagine, what have we gone back to? The fixed, attached keyboard, right? So that's what it was in 1975, 1980. That's what we were having. That's what my brother observed among all these reservations people. And of course, keeping it on the lap puts it way out of the optimal visual field. So I wonder, literally, if this might not be something that our society is going to, have to address. Laptop is most commonly operated on a standard height desk or table. Invariably, the monitor screen is substantially below the optimal viewing angle. This results in the user having to hold his or head and neck in a prolonged, abnormally flexed posture, setting them up for this kind of potential. Little kind of like exaggerated. The one on the right, of course, asks the whole question of how optimal the whole fit relationship might be. But are these familiar? Some of you can relate to this, right, at the end of the day, because it's extraordinarily common, and of course it's so subtle we don't really give it much consideration. But look at where her screen should be, folks, right, compared to where it is. Similarly, right, look at, even though she's slumping forward, her screen in comparison to, optimally position is going to create, over time, lots of examples. So there are really two solution issues, two considerations, two steps. First of all, obviously the biggest, single most important thing is to get a separate keyboard. And of course, readily available, any office supply store will have them. And again, it's an easy, simple fix. The main thing, again, is compliance. Why? Because you got to drag it along with you. What's the neat advantage of the laptop? It's portable, see? And that's the sweet part of it. And every student has one, but you'll see them on these kinds of desks every single day. We see our students, and they're all on their laptops. I mean, they bring it to class, but again, they're all looking down. And of course, that creates this entire set of, muscle responses and so on. The other thing, of course, is to use a support, a stand, if you will. There are a couple of varieties on the market. These are a couple. One of these happens to be ergotrons. I'm not sure. I think this one, I'm pretty sure, is an ergotron design. But of course, it's also adjustable. And here you can see the adjustment is in this. This would be the means by which this is a lever mechanism that allows it to raise. Still, of course, having the keyboard at an inappropriate angle because you're going to force your wrists into, an abnormal extended posture, so certainly not a desirable thing. So the detached keyboard is a critical element, and then the next sort of like potential for epidemic proportion is these handheld devices. And probably some of you are hearing about them already in some of the popular, magazines and different publications. They talk about this text neck or BlackBerry thumb or whatever. And in this situation, obviously, there isn't really an easy solution. I tell kids, that cell phone is a tool, not a toy. How many hours, how many minutes do kids spend on their cell phones? Always in that same posture, right? I mean, it's like, they're creating a neural pathway, are they not? And ultimately, that becomes part of their posture. I often think of like kids who spend 20, 30 hours a week, practicing their violin. I mean, just imagine that posture, right? And of course, does it have consequences? There's a whole study, by the way, of the ergonomics of performers, musicians. Can you imagine the weight of a tuba? Kids going in marching bands and thinking of, carrying that, or the guitar, the electric guitar. I mean, that's suspended usually on a single strap on one shoulder, and they're going at it, but again, it's ergonomics. It's a pretty horrible set of circumstances, and it's much heavier than it looks, right? They make it look easy, but it's a fatigue factor of some notable situations. So clearly the handheld devices, Now texting has become the popular mode of exchange of information, whatever, likely to be around for a long time, right? At least a decade or more. I don't know, pretty soon it'll be probably thought activated, right? Just think about it and the frequencies of your thought will, I don't know. That's not so far-fetched, right? I mean, actually, I think that's, in the future as well. So now the last thing that we kind of want to put a good deal of emphasis and focus on is this consideration of sit and stand options. The growing body of research clearly suggests a health-associated relationship to giving the worker the option of sitting a portion and standing a portion of their day, usually a ratio of about 2 hours per 8-hour work shift. So that's spread out usually in 10 or 20, 30-minute intervals of standing, and then sit, and then go through that same routine. Management should be encouraged to explore the many benefits of incorporating this simple, relatively inexpensive technology. In many cases, all it really does require is an adjustable, desk apparatus. These are a couple of examples of it. You can see in this instance, they also feature where one limb, what does this remind you of? Pardon me? Well, in some measure, but also in the older days of the ergonomics, this could be a tongue-in-cheek. This would remind you of the bar rail. I mean, you go to a bar, they all have that brass rail. And of course, when you're standing at the bar, sipping on your grog, well, then of course your back gets tired. So you'd put one leg up at a time. That's where a lot of this originated, and it was found to, reduce the stress, usually taking some of the stress off the facet joints, right? I mean, that's part of, so this in some measure is a feature on some of these kinds of desks that allows that option to have one foot, and you exchange it and so on. So that's what's happening there. Here you see the worker. One feature again, she's got her screen a little bit lower. She's holding a pretty neat posture. What do you see about her wrist though? So again, where her keyboard should be in relation, right? This does not fulfill this optimal situation. So her keyboard, should have the capacity to go up and down as well. Go ahead.
How about the monitor height for people who are wearing bifocals? What's the best way to assess that and get it so that instead of being in the upper 1/3?
Well, again, instead of tilting their head to accommodate, they may be able to tilt the screen. That's one of the neat features of most. Obviously, every modern monitor now has the capacity to, tilt backward or forward or side to side, rotate, whatever. So in some cases that might do the trick, but as we said, you really want to have a lens that's optimally, I would have a separate pair of glasses. In fact, that's what I use. I mean, I have reading glasses, but for reading a book at 16 inches, that's a different lens for me than having my monitor out here where it belongs. So part of it is my concern about EMFs again, though. I mean, I could pull in my monitor closer to have it like my reading distance, right? Like holding a book in your lap when you're reading, right? That's usually about a 16-inch distance. This is about a 30-inch distance, right? And for me, it's a different lens. So I have separate lenses specifically for computer use. I don't have bifocal or trifocal. I just need reading glasses. My general vision is still adequate for viewing highway, road signs, those kinds of things, or distant viewing. But you're right, in whatever you can do to get that, so that you don't put additional stress on the cervical spine is a big concern. And that it might be accomplishable in some measure by using the tilted screen. So, and this is a book that's recently, it's brand new right off the, it's a 2014 edition. This gentleman, by the way, is out of the Mayo Clinic, and he is one of the consultants for Ergotron. Ergotron has an annual, I think even semi-annual, I've sat in on a couple of them, where they bring in these national experts on ergonomics and ergonomics of the seated worker, and now they're getting involved in the sit-stand movement. And Ergotron is actually one of the national leaders of this movement, and Levine's book really takes significant issue. I mean, he's not kidding about this idea that can your chair, it says get up, what your chair is, why your chair is killing you and what you can do about it. Because he's talking about predisposition to certainly obesity and diabetes, but cardiovascular and COPD and all of these really nasty, what we would consider to be metabolic disorders, such that they're irreversible pathologies, and that's what he means by excessive prolonged sitting contributes to these kinds of disorders. So it's not a casual kind of thing, and it's getting headlines. I mean, it's making public health authorities really pay attention, and of course now more and more employers are heeding. They're saying it can make what is it currently, Chad? Is that 3 to 5 years difference in your longevity even? I mean, it's like they've got these kinds of data that are pretty impressive. You just can't ignore it. I mean, in comparison, it's kind of like, I think Dr. Duncan says that sitting a certain number of hours per day, remember that? Chad, was like equivalent to smoking a cigarette. The equivalent health risk. So that's what I'm getting at, you guys. It's not a casual thing anymore. And of course, it's a whole population of prolonged sitting. That's what we're doing right now, which is not the ideal, but go ahead.
What is your opinion on those sit discs or those wobble discs that people use where you, instead of a ball, they just put it on their chair and then just go through range of motion?
Yeah, again, for individuals, they may find that to be a really neat thing, and anything that they can do to facilitate motion. That's the desirable element of the ball, right? I mean, that's the idea. You can have a certain amount of motion without having to have any detriment that I'm aware of. In fact, it could only be good. However, I think it's kind of individual. If you try to force them on people, I have a feeling there would be those who would resist. But I think the logic of it is sound. I would certainly,
Exercise or is it a seat?
It's like a cushion. It's like an air cushion. 13, you can make them bigger sizes, but you inflate it, and then they can sit on it. And you put it on your chair, just underneath whatever your office chair is. Yeah.
For a while, there was a manufacturer of a chair that literally, it moved all day long. I mean, it moved subtly, but it literally, it was automated. You had no control over it. I mean, you could probably speed it up or slow it down, but I don't think it caught on either. It was one of those, here and then gone tomorrow. But that was one of the ideas, is to facilitate mobility and movement, motion.
I was going to say, something like that sit disc, I think that they're great for using it for taking a break to run but when you're having to sit on them, your muscles have to be actually be activated, stabilized, just like the therapy ball. Where if you're sitting on that thing, you got to use postural muscles to hold you up, where you can rest in a chair, and then so I think that's a better use of those types of things for intermittent exercise and range of motion restoration.
Sure. And even slight, subtle motion is so much better than pure static, lack of non-motion, so to speak. And then this book is another one that you might want to think about. This is a former NASA engineer, scientist lady, and her book is entitled Sitting Kills, Movement Heals. Everyday movement will prevent pain, illness, and early death. Exercise alone will not do it. So she's basically saying that, just any form of movement, and then to not let people feel the guilt, remorse of not being someone who loves exercise. Because as you know, a lot of people just feel resentful. I mean, they don't like to do exercise. They feel it's a great big burden, and then they feel the guilt if they're not exercising. She said, don't worry about that. Just move. Just do anything at all that facilitates movement, and don't feel guilty about the fact that you're not like an athlete or whatever, because a lot of people it's not part of who they are. And in fact, and when it's forced on them or assume that everybody is going to enjoy this or that they would find it something, easy to comply with, she's basically saying forego that guilt. Don't be concerned. And that's kind of a neat, message for society to think about. This is kind of an innovation too. And Dr. Levine, the Mayo Clinic doctor, was one of the innovators of this system, where you're actually walking on a treadmill while you're word processing, so to speak. Again, how popular, how reasonable, how logical, how What would we say return on investment? One thing I would say again, maybe great, but I would give the worker an option. I would never try to force this, right? In other words, if the employer has some of these available to workers who would like to do that, I think it could be a great tool. Quite frankly, I don't know how many are in use right now, but I think it's innovative. It's certainly an intriguing idea, is to whistle while you work or whatever, walk while you work. And Ergotron, I mentioned here, again, world-class manufacturer, distributor of ergonomically correct, adjustable sit-stand workstations. They're also a pioneer in this whole movement and have been engaging in some serious research. They've got probably 4 or 5 major universities that are doing research on their behalf, where not necessarily that Ergotron is paying for that research, but they're using Ergotron equipment, and they're again holding it in terms of really high value, which is again a fringe benefit to their company and whatever. So, and again, you can just go to their website and learn more about them. I don't know if we want to take the time to do that, but certainly worth your taking the time to do so. I want to give you guys another break, and then we also want to give you time to do your exam. Also do a critique of the weekend. So well-informed management will be wise to provide seated workers with the option of either sitting or standing at their workstation throughout, and through the provision of high-quality sit-stand equipment. However, as mentioned, they shouldn't feel coerced. They should feel that they have the right to say no without the feeling of guilt, and or that they're going to be in trouble if they don't. Obviously, a lot of this having to do with, if you're overweight person, significantly overweight, and static standing, very short while, you're going to find your feet, your knees, they're going to say, oh my God, I can't handle that. I can't handle it on my varicose veins or whatever, right? You got to get that, realization that, what is it, 1/3 of the population, Does that exclude workers? No, including workers are obese, right? And then again, there's another percent, it's another 30% that are at least overweight. And you ask these people to, spend 2 hours standing instead of sitting. By the way, why did you guys sit for this event? See, he isn't sitting, and nobody said you should or shouldn't, right? What I'm saying is it's somewhat cultural, but it's also more comfortable. I mean, if you had to stand still for any length of time, it's going to be an issue. So even if I were standing at my standing workstation, right, I'm going to do this, right? I mean, I'm going to try to keep some mobility going rather than simply standing. And if you're concentrating on what you're doing, you might not be moving your lower limbs that much, even though that would be the recommended thing to do. So kind of put that in perspective. All of these things, very meritorious, probably having a great deal of logic in the world of physiology. We know that it does. There again, you're dealing with the behavioral component and, gaining, if you will, this concept of buy-in in terms of the end user. So then, finally, in conclusion, we'd like to say, even with the incorporation of the world's most advanced and sophisticated ergonomics technology and workplace design, if unhealthy, undertrained, or improperly motivated workers are assigned to high exposure tasks, there will still be an unacceptable number and severity of neuromusculoskeletal disorders in the general workplace. For this reason, as part of our formula, our solution to it, of course, is yes, you can be the best ergonomist going, but take a look at these issues, right? It's kind of like, okay, cool, but you have to really understand human nature prevails, right? So all of these elements come into the question of how much influence will you really have on the worker. Let me comment, though. This is what Chad's common message to the end user is you call it a champion, right, Chad? See, the HR director sees this as well. But the HR director, the full-time employee whose responsibility is the health and wellness and the safety of their workers. That's HR department, work activity. But they may see this worker maybe every 2 weeks, maybe every 3 months. HR directors never come to my office and checked out my workstation, I promise you that. In the 27 years that I've worked here, I've never had a knock on my door from the HR department. Does that make some sense? That's their job, though. So what Chad is saying, this is the advantage of being on site, right? And that worker who has this, shall we say, freedom to access you for any number of reasons, including the body, mind, spirit, right? All of this consideration can be so very, very valuable. And realizing, again, you're dealing with a lot of these issues. You have an individual who is dealing with anger issues. You have other people with various levels of indifference and apathy and whatever. And so with that, of course, all these lifestyle considerations, smoking, nicotine, alcohol use and abuse, nutrition, food, exercise, movement, diversion, and then any kind of attitude, right, with regard to attention to ergonomics while they're off work, right? Because that's another thing. We kind of think that it's, ergonomics is just an 8-hour deal, right? And you have to realize, of course, that people spend 2/3 of their waking life off work. And again, how are they using their body and what kind of environment do they have, which may be countering, in a negative sense, all the good things that you're doing for them at the workplace. So that has to be part of our message as well. That would be what you folks will want to be considering. Beds and pillows and sleep postures come into the picture. And of course, we highlight this last one, this idea of buy-in, their mental attitude. And if they come, see, there is a kind of another tongue-in-cheek expression. They may refer to you with a slur, referring to you as the ergo cop, right? And somebody that, it's kind of like the highway patrol. Right? I mean, they're out there for who? For you, right? The highway patrol is interested in preserving your neck. But a lot of people don't think of them as that, right? They think of them as another, like interference in our lives. Similarly, workers may perceive, you guys, right? that we're somehow, an interference. Not realizing, of course, that really we're there on their behalf, which is, again, sort of the step that might be the most challenging for all of us. You can do all this high-tech science stuff, but your challenge may well be this issue of getting the worker to understand that you're there on their behalf. And like we say, that's a really critical thing. And then we kind of use this, sort of one of my own renderings as you can't be any healthier than your spine is. And because your spine is so critically related to good health, you have to, if you want good health, take care of your spine. If you want to have a good spine, take care of your health. Your spine can't be any healthier than you are. So your general health is of primary concern over and above all of your other neuromusculoskeletal issues. I'm going to say it's of higher or lower priority. Again, that's individual. For some, it may be one. For others, it may be the other. But that's kind of where we're at. It's time for a break. I'm glad to respond to some additional questions. When we come back, though, we're going to sit you down and have you do your exam. And then we'll also be really grateful for your critical feedback and suggestions. For educators are always very, very sensitive about what, when I go home this evening, I will say, oh, cripe, I forgot, I should have, we all do that. We're all human. And you're going to be in the same position, right? You're going to be talking to those employers and those workers. You're going to go home that night and say, oh, cripe, I forgot. Anyway, we're always trying to improve on what we're sharing and why we're doing it and whatever. So please be candid in terms of providing critical, constructive feedback. We're always grateful. The institution's always very sensitive about that as well, because they want to be sure that their product is appreciated and that you'll send your friends and family, just like, referral of your personal private practice. So any questions before we formally break with the informational sharing? Observations, other comments? Go ahead, Al.
Just one. I really like Dr. Chestnut's kind of paradigm of talking about movement as a nutrient.
As a
nutrient.
Oh, okay.
Just like air is a nutrient, our food is a nutrient, movement and proprioception. How powerful that is, and I try to change people's paradigms. Like, well, you would consider not eating Would you? Well, or you were not breathing, you would understand that. Well, your body requires movement. Why would you, movement deficiency syndrome, is another way to kind of paint it for people who maybe hate exercise. It's like, well, you may hate it, but it's an essential ingredient to your health. So,
kind of reminds me then, Doc, is like when we talked about the 4 ingredients for life to exist on the earth: air, water, soil, food, oxygen, sunshine, those things. Well, but then we said also sleep. It's critical for life to be preserved on the earth. And then the sentimentalists would say, but love, the idea of caring, nurturing of infants. Without that, of course, we would perish as a species. And then, though, you're saying the idea of movement, how critical is that for life to exist? Well, bedridden people, do exist. I mean, often when a quadriplegic, has no motion. Many of them are bedridden for decades. So you have to put that into perspective. We realize there's an ideal, but it's amazing the human resilience, right? But I agree, absolutely, for optimal, without a doubt. And it's something, again, that we take for granted. Even when we're sleeping, we move, right? We move even unconsciously, we move. We shift because, of course, it's the same idea. We need to mobilize. We can't let static loading. That's why so many people, especially obese people, develop like bursitis of the shoulder, bursitis of the superficial trochanteric bursa, just because of static accumulation of toxic waste material. And of course, you've got bony surface on a hard bed, because a lot of these obese people have had problems when they're recommended to get the hardest mattress, and then ultimately they wind up with bursitis in their shoulder or their elbow because they got all of that body mass. You take a 300-pound person, all of that physical load on those sensitive soft tissues, and pretty soon you've got another problem. And so anyway, it's been delightful on my part. I'm hopeful that this has been productive. Take a breather then, and then Adam, you'll be passing out their exams, and do the best you can. It's an open book exam, by the way, so you can refer to your notes, and do take your time. We want to be sure that you feel comfortable with what you're doing. So.